All right, what's up? What's up? Uh, we're live on Twitch with some more live interview preparation. I think today it's just going to be the same as the last couple of days. Well, yesterday was different because I was solving some of the uh, challenges from the LeetCode contests over the weekend. But today, let's just get back to looking at some LeetCode questions. I might actually start with something slightly different today, which is I haven't played coding games in a while, and they are fun. They are fun. Coding game. So maybe I'll look at a few of these. Here, let me log in. I think it's also possible to play this game with viewers. Of course, I need viewers to do that, but I can also just play with random people on the internet. So let's mess around with coding game a little bit to begin with, and then here. Then I've got a couple of LeetCode questions to do, including, importantly, I do want to take a look at these two questions here, Jump Game and Jump Game 2, medium level dynamic programming problems that are part of the DP study plan that LeetCode provides for dynamic programming. So I'm going to take a look at that at some point, but let's start off with some coding games. So let's see. Oh, it looks like they've stylized the title of this to coding game. Let me update my stream title so it has the same. So it's coding game. Coding game without an S on the end. So let's see here. So I haven't been to this website in a while, and it looks like they've made some changes. So let me just check this out. Welcome on Coding Game. Passionate developers learn, train, chat, and have tons of fun. Great, that's exactly what we want. You can explore the site by yourself, or you can click below and let us show you around. Let's take a look here. Let's just look at what they've done to the website real quick. So onboarding, solving this puzzle helps you understand how the puzzles work on coding games. Okay, so the input parsing, game loop, writing to standard output. Okay, so this is not quite what I had in mind. I wasn't thinking that of like challenges where you write software to like control a robot. Aren't there just like normal little challenges where they give you input and expected output and you have to solve those? That's kind of what I want to do. So let's go to compete here. Clash of Code. Join a 5-minute coding battle. That might be what we want. What's this? Optimization. Try to reach the best possible score. Coding game. Reverse engineering. Honestly, I don't actually know what to do. It might be is it the reverse engineering one? Let's take a look at this. Okay, no, I think Clash of Code, right, is what I want to play. Clash of Code is a game to improve your coding efficiency by solving short programming problems with other people at the same time. Players can share their solution at the end of a game to help other players improve their coding skills. Yeah, this is what I want. So join a clash is one option. You can also challenge friends, and you can start a private clash. So at some point, if people are interested, like it doesn't have to be today, but at some point I think it could be cool to do some private clashes. But let's just let's see how we doing here. So we've participated in 31 of these. It's been a while, and 124k out of 400k, so that's not very good. But Clash of Code is what I had in mind. So I'm gonna update the stream title again. So Clash of Code. So Clash of Code is in the stream title. Okay. Let's start off with just a Clash of Code, and I don't really know what to expect because it's been a while since I've played this. So let's just join. Okay, so we joined, and we're waiting now for more people to join, and let's just see how it goes. Let me update my stream title again. I think it should probably be etc. instead of misc. What tags should I add to my stream, by the way? Programming, software, I don't even know, software development. What else? Coding? No, it's not an option. Oh, it's starting. It's starting. Okay, let's take a look. Let's take a look. So the shortest mode. We're supposed to produce the shortest solution, I think. Input 2 lines, space separated integers, begin and end for the beginning and end the segment respectively. And whether or not they overlap. Wait a minute. Wait. So is it just if end 1 is greater than begin 2, hold on. Python. Sorry, it's been a while, so I don't expect to do very good. So Python is the language. So if end 1 is greater than begin 2, then print overlap, else print not overlap. Is that right? Or the other way, right? Or end 2 No, it's actually not quite. So what, there's so if end 1 if end 1 is greater than begin 2 and end 2 so is there just a really nice way to write this? Do I have to like add a whole bunch of cases here? What can I just do how do you do a Python set intersection? No, this is going to be too slow. So let's rename these variables to B1, E1. Also, where's the timer? 11 minutes and 30 seconds left. And I think there's probably people competing here that already have a working solution, but because we're in shortest mode, it makes sense to not submit right away and wait a while to try to literally make your code as short as possible. So let's get rid of that. Let's already just go ahead and shorten this up. Even though I don't actually have a working solution yet, but it's going to be B2, E2. Actually, like, because of the mode we're in, you literally want to do like this, ideally. Does this run? Okay. So we need to figure out code size 100. My code size is 73, but I still have some code to write. So we need to figure out if there's an overlap. So what are the possibilities? What are the options? So if, well, let's think about it this way. If the end of B is less than or equal to the beginning, if the end of the first one is less than the start of the second one, or even if they're equal, then there's an overlap, right? Or if the end of is less than A, print overlap. How many minutes left? 9 minutes. Print else print not overlap. Failed test cases. So for test case 1, can you see what the test cases are? Do they show you? So A, B, C, D. Oh wait, it's reversed. This is the not overlap case. And then this is the overlap case. Okay, so the good news is it looks like we actually did solve the problem, and so now P equals print. Oh wait, we don't need to do that. So what we do need though is we need this condition. So if we're trying to shorten this as much as physically possible. The person in first place right now shortened his to 100 characters. So let's see if we can beat that. So it's probably going to be tricky. I can see some optimizations that we can make, but we do need to print, and we need to print not overlap if the condition, else overlap. Okay, so okay, so he wrote his code in C, and he got it down to very fucking short. So something else that we can do here is we can have I I equals input, right? We can do that. And j equals int is something that we can do. And then this just becomes j. This might save us a couple of characters. Let's change this to k for input. And so then these would be k. How much time is left? 5 minutes. I don't think I'm gonna do very well here. Okay, we got our length down to 129. Oh my god, dude. Yeah, I don't think I'm gonna do very well here. Like, first place now, he managed to trim his down to 78 characters. Let's see. So we can get rid of some stuff there. We can probably... Does that still work? Okay, so that's okay. So we got ours down to 123. What else? What else? So the question is, would it be better to do A, B equals man, I don't know. I don't think this is kind of a silly game mode. I think I'd rather just submit with my 123 and look at their code if they decided to share it. And see. Okay, so I'll share mine, even though these two players did it better. So let's take a look. So the C solution. Okay, I had a feeling someone was gonna do. I had a feeling someone was gonna take the verlap part of the output, and it's like pull that out and either put uppercase O in front of it or put not O in front of it, so you get overlap and not overlap. And this person did do that. So let's see, what did they do? ABCD equals dd dot split dot map ampersand. Yo, I don't even... Oh, this is not the C solution. This is the Ruby solution. I cannot read what's happening here. Let's take a look at the C solution. Oh yeah, okay. So the C solution is using scanf. That's actually smart. And then they're doing the same thing with overlap. Yeah. Okay. There's still 3 minutes left. A bunch of players haven't submitted. I might... Do I want to do one more? I think I'll do one more, and then I'm going to go to LeetCode. So let's play again. Let's play this mode again. Just for fun. Reverse mode. You have to guess what to do by reversing the provided set of tests. So if they give you a 1, they want you to do this. If they give you a 2, they want you to do that. If they give you a 3, they want you to uppercase every other letter. Okay. Okay, and this is not shortest mode, so we don't have to worry too much about that. This is whoever gets it done first, which is so a little bit more pressure. If method equals 1, then print, let's see, so print input print. Let's call this just s, and we'll call the method m. So if the method is 1, print s dot. Let's see. We want to do a regex replace. Python. Oh, should I be doing this in JavaScript? Yeah, I should, because I know a little bit more about regex in JavaScript. So let's switch over to JavaScript. We'll still have s and m. Oh wait, what the hell? Not Kotlin. JavaScript. Okay, so let's get rid of all that. Get rid of all that. S and m. So if m is 1, then console.log. So basically what we want to do is we want to strip out s.replace. We'll replace regex with empty string. And the regex is going to be white space, which would be /w, g here. Okay, so uppercase W, maybe? Yeah. And then we want to force it to be to lowercase. So dot to lowercase. Dot split on empty string. So now we get that. Now we want them. What happened? Don't know what that ping was about. So the next thing we need to do is, so we've got it in an array. So dot join. Space. So if we play the first test case, we get it right. Okay, someone already solved it. Let's see how fast we can get it. So if m equals 2, then it's the same thing, but we want to uppercase. If it's 3, then it's so it's this. It's gonna be this. So after we split, we map. And we get C and I, and then we return. We're gonna have a ternary here. We're gonna do I mod 2 equals 0 question mark, and then C dot to uppercase to lowercase, or C dot to uppercase, and that might be backwards, but rather than think about it, I'm just gonna see. Yeah. So I mod 2 equals 1. We still have to join, but not with spaces. Try 0 again here. Okay, and then last but not least, if it's 4, then it's the same except the odd numbers, else console.log s, I guess. And what happened with looks like it's removing the special characters. Why am I removing? Is it something to do with my regex? Let's try something else instead. We'll do something like this. So what it wants you to do is, it's not the index that matters, it's the number of the letter, which makes it a little bit more annoying. So we're gonna have to code that up. So, fuck, it's gonna make me take longer to get my solution in. So let I equal 0. And like that. This is what we're going to return. Let I equal -1, and then if, how much time is left? 6 minutes. If let's just regex it. If c dot match like this, we know that it's just a string with a single element, so a to z. A to Z, so we know it's gonna either match that. It's gonna, oh wait, yeah, this is right. So if it matches, otherwise we return C right here. And then here, this is going to be I++. We start I off at 0. Let's see what happens if I play. Oh, there's only 3 methods. Oh, submit. Okay, we got it. We got second place. We got second place in that one. First place over there, Noxy46, nice. He got them a lot quicker than I did. Like, he got them in 3:39. I didn't get it until 9:38, but I will share my code. So let's see what. So honestly, these lines down here, completely unnecessary. All it cares about is when m is 1, 2, or 3, and we just had to keep track of like when it's a letter versus when it's a special character. So we got that. Let's take a look at Noxy's solution, which is in Ruby. So method 1, s.downcase .chars.join s.upcase.chars.join. Crazy the stuff you can do in Ruby. And then yeah, we got his case for when the method equals 3. Yeah, very similar to what I did, but obviously he submitted it a lot quicker, so cool. Well, that's gonna be it for, I think, Clash of Code for the day. I'm going to go over to LeetCode. Good luck to the remaining 6 contestants. And yeah, so we'll go back to LeetCode. This is the problem I'm going to solve. I'm going to jump right into it as soon as I take a quick bathroom break. So, yep, be right back. All right. I'm back. Let's switch over to the chill station. Chill out a little bit. There was actually something that I wanted to share before I jump into some LeetCode questions of increasing difficulty. So let me just share it real quick. So, as a new streamer, the software that I'm using to stream and to like compose all of my video and audio and all the sources and all that together into a canvas that gets streamed to Twitch and also gets recorded to a video for YouTube. I'm using OBS for that, and OBS lets you like hook into all the internal like workings of it and events and stuff like that using code if you want to. So it supports Python scripts and it supports Lua scripts. It also supports plugins, which I think you have to write in C or C++ or something like that. But because I know Python, I thought to myself, I should give this a try, you know, because as a new streamer and as a person who's been writing software for quite some time, it seems like the perfect opportunity to create, you know, cool customizations for the stream just by writing, you know, Python code. So I spent some time researching. There's pretty good docs and stuff. So I found this repo on GitHub called, it's like the OBS Python cheat sheet. And so they basically just have like this nice long list here of things that you might want to do using your script, and I can share this repo because I think it's cool. They have a long list of things that you might want to do in OBS while you're streaming as a script. And so this GitHub page has been very helpful. So what I'm building up to is I actually did write a short script to do something in my stream that I wanted to be like automated. I didn't want to have to do it myself every time, and I'll tell you about it in a sec. The other resource that I found helpful was OBS's own Python scripting homepage and the API reference. So obsproject.com has some pretty good documentation as well about what you can do. And then in addition to their like Python and Lua specific like reference, they also have an API reference, which is it's directly, I'm pretty sure it's directly defining their like low-level C/C++ API. I can't remember if it's C or C++, but it's one or the other. So all three of those pages was extremely helpful, and so let me show you what I did. So if I hold, I got you. So I wrote this code today. Basically, what the situation was is that I have some scenes on stream where I just want the mic to be muted automatically. So like for example, I have this. So one of the issues is that it works. So if I show you the scene, it's gonna mute me. But so I have these scenes. So I'll just click through them real quick. The scenes are the starting scene, the BRB scene, and the ending scene. So these scenes. So those are the scenes. And so anytime I switch to those scenes, I just want to automatically mute the mic, right? Because, you know, if I'm be right back, maybe I could be like talking to someone IRL. Maybe I'm flushing the toilet, which is, it's not too far away. So there is a chance the mic could pick that up. In the kitchen, you know, if I'm putting a dish in the sink or something, just make sure that the mic's muted so it doesn't pick up a clink clank or anything unintentional like that. And so by following those guides that I just showed on stream, this is the code I came up with. So this code is pretty bad, and I'll get into why and what I'm going to change about it to make it better. But it is my it's like the first iteration of the script. It's also my very first like custom OBS script that I wrote just by following like the guides and the cheat sheet and the documentation. So essentially what I've done here is I've defined the names of the scenes that where when OBS transitions to them, I want to automatically mute the mic. So these are actually these are the names that I have assigned within OBS like to these scenes. The reason why they all start with 2560 is because this is at the monitor, like my primary monitor is an extremely wide monitor where the full resolution is actually 5120 by 1440. So it's a super ultra wide monitor, and it's not ideal for streaming. Although when I occasionally stream gaming on my other channel, I do stream at the 5120 resolution, at least for now. I probably won't always be doing that because it's not quite as watchable, unfortunately, as a 16:9 stream, right? So my full resolution is 32:9, and when you stream it, it's just not quite as watchable as 16:9. So anyway, because of that, I have starting BRB and ending scenes within OBS where I have two of each. One of them is the 2560 width for the 16:9, and the other one is the 5120 width for the 32:9. So right now, this script, I'm just using it for the 16:9 stream, so the coding stream. So these are the scene names where when OBS switches to them, I want to automatically mute the mic. So within your Python script, in order to so essentially what OBS does internally is whenever certain things happen during the stream, for example, a scene change, it could be something else too. It could be you muting or unmuting like an audio source. It could be you adding or removing an item to a scene. Like there's a lot of different events that you can listen for, and when those events happen, OBS like broadcasts that event in such a way that your custom script can react to it, can handle it. Essentially like listen for it, right? So when you write your script in a way that subscribes to these OBS events that get fired. And your subscription is like a handler function where you can then do additional things to, within OBS in response to these events happening. So the way that you, oh shit, hold on. One of my lights went out. Okay. So the way that you can subscribe to these events is you create this script load function. Anytime that your script loads within OBS, it automatically looks for this function, this exact name, script_load, all lowercase, and it runs what's in there. And then one of the things you can do in there is you can specify that you want to add a callback function for front-end events, where like the scene changed event would be an example of one of the front-end events. So I basically say, hey, OBS, whenever there's a front-end event, just go ahead and call my function. So I have this onEvent function. Now this function, you can call whatever you want. You could rename this to handle event if you want. But the script load function does need to be written this way. Okay, I'm going into more detail on this than I had planned, but I am excited that I wrote this and that it works. So the next thing that you do is you implement your callback function, and what you can essentially do is you can have code that runs depending on what the exact event is that happened, because there's a bunch of front-end events that OBS will broadcast. And so in my case, the only one that I care about right now is when the scene changes. So per the OBS documentation and like the API reference, they have this event called OBS frontend event scene changed. And whenever the scene changes for any reason, one of the reasons might be because I manually transition to a different scene, this will happen. And so then OBS gives you a function call to get the current scene. In this case, you're getting the new scene. You're not getting the previous scene. So we want to know what the new scene is. So we say, hey, front end, give me the current scene, and we get it. And then we say, there's another OBS built-in function, and we say, hey, OBS, get the name of the scene. And in this case, a scene is a type of source within OBS. So calling source get name gives you the scene name. And then the rest is fairly straightforward, right? So I already defined my list of scenes where I want to mute the stream automatically. So I just say, okay, if the current scene name, which is the scene that OBS just transitioned to, if it's within the scene names array up here, then I want to mute the mic. So the way that you do that is you get the mic source. In my case, within OBS, the mic source is called this exact string right here. This is the name of it. I have it called mic/aux. I don't even think I called it that, honestly. Like whenever I was setting up OBS to like start streaming, that source was already called that. So mic/aux gets the internal like OBS source for the mic. And then once I have that, there's this function call OBS source set muted. And so I pass the source to the function along with true, indicating that I want to enable the mute. Hold on, the light went out again. I think I keep touching like the plug down there with my foot. And yeah, so that's it. That works. Then you basically just have to go into OBS. Within OBS's UI, there's a scripts section, and you can basically just give it, it'll open a file explorer, and you can use that to navigate to like the scripts that you've written. So for example, this one I have called mic-muted-scenes, and it'll just load it. And it works. It works. Like you know, if I'm talking and I switch to one of these scenes, the mic will automatically stop. So let me just sing ABCs. A B C D. And then the only other thing is once I come back to a scene after that mute has happened, like if I come back to this like main scene, the coding scene, I do have to remember to manually unmute the mic, which is something that I think I can get used to. I just didn't want, so the thing about this script is I didn't want to have to remember to manually mute when going to one of these like starting BRB or ending scenes. But So I want that to be automatic, but I don't mind having to remember to unmute. So yeah, that's how this works. How could I make this better? So the changes that I'm about to describe, I am gonna do. I'm not gonna do them right now. I'm gonna do it later, and then maybe on another stream I'll explain how I did it. But so it's what's bad about this is that I have these scene names hard coded, right, in an array, and I also have the name of the mic audio source hard coded as a string. And so right now, the problem with this script is if I like rename any of those within OBS, this script just breaks. And so that's a problem for me. Also, this script is completely unusable by anyone else because right now the script is very specific to the exact names of my scenes and the exact name of my mic source. So how do I make this script better? Thankfully, OBS lets scripts define sort of like a UI, except it's not really a UI. OBS lets scripts define properties that the user can set to control how the script works. So for example, whenever I go to the scripting section of OBS, I'm not going to do it on stream right now, and I go to this script, there's code that I can write within this script that lets me specify that when I go to that section of OBS's UI, it should ask you for, it will actually give you a drop down where you can select scenes, and like you can select like what your audio source is that you want to mute. Maybe you have multiple audio sources that you want to mute when these scenes get transitioned to. So you can set it up so that the user of the script is able to, so the streamer is able to specify that. And then the other thing too is because you would be using like basically a drop down of all your scenes, the behavior wouldn't actually be tied to the name of the scene. Under the hood, the behavior would be tied to like the unique ID of the scene. That doesn't change when you rename it. So for example, I'd be able to go into OBS, go to my my BRB scene and rename it to something else, and this Python script would continue to work. So okay, so I've rambled on about that for a while. I think it's pretty cool. I think it's pretty cool that OBS lets you write Python code to control the stream. So I've taken advantage of that, and I've written my very first OBS custom Python script. And yeah, all it does is when I transition to some certain scenes, I just automatically mute the mic, which is nice because it saves me from having to think about that. I will make the improvements to the script at some point. Could be later today, but it won't be on stream. Yeah, I honestly, like, this is a very simple use case for a Python script. There's a lot of stuff you can do. You can basically control like any part of the stream using Python or Lua from your script. So hopefully, as I continue to stream and continue to understand this API, this like Python API from OBS, hopefully I'll be able to do some cooler stuff. So yeah, that's actually all I wanted to say about that. Yeah, there's gonna be more stream customizations coming using Python. Cool. So that's it for that. Let's go back to LeetCode, since that's supposed to be the more interesting part of the stream. Okay, so as per usual, I'm starting with some easier problems, and then I'll be progressing to some harder ones. Oh, cool. Okay. Twitch just sent me a push notification saying that I can manage the stream from my mobile dashboard. And the reason it did that is because it saw that I'm live right now. So that's nice. I don't think I'm going to need to do that right now, but it's good to know that that's an option. So this problem is very straightforward. Let's see if I can solve it extremely easily using Python here. So obviously, in order for two strings to be anagrams, they have to have the exact same letters and the exact same numbers of those letters. So let's just create a counter for a string s. So s counter would be sc. Let's get the counter imported. So from is it collections, import counter. Hold on, let me move my keyboard because I'm having trouble typing. Okay, so counter, and we're gonna make a counter from string s. Then we're gonna make a counter for string t. And okay, this is the part that I'm not sure about. I would love it if I could do this. I would love it if I could do that. Is Python gonna let me do that? It is. So there you go. How do we make this even shorter? So we can solve this problem in one line of code just by creating the counters on the fly, like this. No reason to store them. No reason to store them in their own variable. So you could do it that way. I believe I also don't need the return statement here. So that's false. That's false. I do need the return statement here. I think I was thinking of an older version of Python. Yeah. So I don't know if I need to go into much more detail on that. So the counter object is really nice in Python, especially for easy problems that require you to count like the number of occurrences of something within something else. It doesn't only work for strings. Counter works for a lot of different things. And so essentially Python has implemented equality for counters such that if the counters contain the same information, they're considered to be equal. So that's why this works, and it's really nice. Let's see. Hold on. Let me just look at what these next challenges are. Find resultant array after removing anagrams, and palindrome permutation. Because this one was really quick. Let's see if either of these two suggested problems requires a counter. Okay, you're given a zero-indexed string array words where word sub I consists of lowercase English letters. In one operation, select any index I. It can't be on the bounds. Wait a minute. I has to be. Oh, it just can't be the first. Okay. So in one operation, select any index I such that I is not the first index. And words I-1 and words I are anagrams, and delete words I from words. Keep performing this operation as long as you can select an index that satisfies the condition. Return words after performing all operations. It can be shown that selecting the indices for each operation in any arbitrary order will lead to the same result. So that's kind of like, I don't know why maybe they said that because it's an easy problem, but I feel like that's something that usually, maybe if the problem was medium instead, you would have to figure out by yourself. But I guess for the easy problem, they just tell you that. An anagram, yeah, we know what an anagram is. Okay, so for the first example, we get ABBA, we get BABA, we get BABA, we get CD and CD. And it looks like, yeah, the output is CD and ABBA. So, So can we use a set of counters for this? Can we do this? For S in words. Here we make a set. Oh, so let's do s equals set. And it'll be we need counter. So from collections import counter. Yeah, any problem that has anything to do with anagrams, most likely you'll be able to use a Python counter to help with it somehow. Yeah, so counter. We'll just call it. We'll call this scene, or we could call this like unique. Equals counter of s for s in words. And then if we print the number of things that are unique, I imagine that will be the answer. Let's see, unhashable type counter. Oh, counter is not hashable. Really? But we can hash the. How it, wait, that's lazy. That should definitely be something that they can hash. Okay. So here's an easier solution. List of s sorted. A sorted list from s, then converted back to a string. So is it dot join on empty string? It's not. It's the other way around. So it's empty string dot join, and then that goes there. Empty string dot join the sorted list from s. Okay. So I think that works in that. So basically, what the output is my output that I'm printing to the console is the number of things that will be in the actual output, right? So I'm detecting here that there's going to be 2 elements in this array, and I'm detecting that there's going to be 5 elements in this array. But we still need to produce an answer. So So here's the question. Because of the way that the problem is structured, so the one that we delete is always the second one, which means that it's the first instance of each anagram that makes it into the output. Okay. So here's how we print our solution. So let's just create our answer and return it. And then what we're going to do is we're going to go over all the words. So for s in words. And then if we're going to do this again. Is that right? It's this. Yeah, it's this. This is basically the key. If this exists in unique. Okay, I think this is a better way that I can write this, but let me write it like this for now, and then I'll show you how you can improve it. So if the key is in unique, we gotta make the key. So this right here is the key of the string. So the key is this. because we're just sorting the letters. So if the key is in unique, here's what we do. We put S in the answer, and then we remove it from unique. So we don't. We're basically saying we're not going to add another anagram of the same thing. So unique dot remove the key. Okay, submit. 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 Wrong answer. Oh, I misunderstood the problem here. They have to be consecutive. They have to be consecutive. They have to be consecutive. So we could solve this with 2 pointers. So basically so the input is going to have a bunch of words where some of the words are consecutive anagrams. And whenever there are consecutive anagrams, you want to just keep the first one of that list. Is that right? Which is the one that gets deleted? You delete words I, and you keep words I minus 1. No, wrong. So when you find a subarray of consecutive anagrams of each other, it's the last one that you keep, because you're always deleting. Whenever you're looking at these like pairs, which is how the problem is described, you're always deleting the first of the two. So once you've done that a bunch of times, the one that you end up keeping is the last one. Okay. So we've got some stuff here that's right. We've got some stuff here that's wrong. Okay, so here's how to go about it then. So let's start off with our here. The only thing that I'm going to keep is this. Let's define that as a function. So let's get rid of our counter, and we'll def get key of S, and it's going to be this. So essentially the key of a string is just that same string with its letters sorted. So the question is, hold on, we're gonna let's do some Python science. Do I need to split the string into a list first before I can sort it, or can I just sort a string? Can I do this? Is this what I want to know? Is this okay? So let's find out. So let's return our answer, and then let's just print get key. Let's have this get key and get key 2. What is get key of A, B, 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 A, and what is get key 2 of the same thing? So do both of those work? That's what I want to know. Do both of those work? No. No. Get key 2 almost works, but so it looks like what happens is get key 2 does sort the string, but what you get back is still a list. So wait, so is this a thing? What happens if I do stir of a list? Will it automatically join it by empty strings? Maybe it won't. That didn't seem to work. What about if I do empty string dot join sorted S? Okay, that works. So basically what we discovered here is that this works. You can just join the result of calling sorted on the string. And effectively what that means is if you give sorted a string, it just does this probably internally. The first thing it does is it just listifies it into a list of the individual characters. So that's just nice to know. Okay, so let's just go back to get key. Okay, so now we need to code this up slightly differently. And the way that we need to code it up is, instead of like globally looking for anagrams across the whole input, what we're now looking for is these like subarrays of consecutive strings that are anagrams of each other. And whenever we find those, it's the last one that we keep. So let's have last is going to be -1, and last is going to represent the last string that we looked at, I believe. Oh, so we could do last equals word 0, right? And then we could just skip it. And then we're gonna have a for loop, and then after the for loop is over, answer.append the last thing, right? So that's a little confusing to look at right now, but that's gonna end up being right. So now what we do is we iterate through the rest of the strings in words, except that we skip the first one, like so. Also, I did mean to share this LeetCode problem in the Twitch chat, so there it is. Okay, so I think this is actually pretty simple. So if the key, we want to get the, so we want last, and we want last key as well, which is just going to be the key of the last. So now S key is going to be get key of S, which is the current one. So now if those two are the same, right? If the last key that we saw in the previous iteration, if that's the same as the S's key, then these two words that we're looking at are anagrams of each other. So we don't need to update last key, but we do need to update last to be S. Right? On the other hand, what if last key and S's key are different? That means that they are not anagrams of each other. So that means that the last one that we saw needs to go in the answer. Because now we're starting potentially a new subarray of consecutive strings that are anagrams of each other. So we append the answer to S. We append S to, no, we append last to the answer. Then last becomes S. So last becomes S anyway. In both of these cases, last becomes S, which makes sense. And last key is S key. And we've also optimized this a little bit now, because the get key function, which does a sort, happens at most once per string in the input. Okay, so this looks mostly right. I think there might be something missing here. Wait, it expected the first one. It expected the first one to be in the array. What? So let me look at this again. You're given a 0 in next array. Words I consists of lowercase English letters. In one operation, select an index I such that it's not the first index in the array. And the two consecutive words I minus 1 and I are anagrams. We delete words I. Wait, no. I think, is the description wrong? Is the description wrong? because, so we're looking at, theoretically, that we're not quite implementing it this way, but, well, anyway, theoretically, we're looking at 2 consecutive indices in the input. If they're anagrams, we're deleting the second one. Oh, okay, yeah, no, I do have it backwards. So if we're looking at 2 consecutive strings and they are anagrams, we delete the second one, so we keep the first one. So the first anagram that we see is the one that needs to end up in the answer, not the last. So first, let's rename this to first and first key. So the first element of the input is always just guaranteed to be in the answer, although that might not be the right place to put that line of code. Okay, so let's rethink this. So we get the key of S. Okay. So if S key is not equal to the first key, then that means we're starting a new section. We're starting a new section. We've already added, I think, so we're going to have an invariant in this loop, which is that anytime we come into it, the first element of the current segment is already in the answer. That's the invariant. So we enforce that by starting answer off as first. I think that means we're not going to need a line of code here. So if the key of S is not equal to the first key, then first key equals S key, and answer dot append S. Okay, is this right? There it is. Okay, so that's how you solve it. So that's how you solve that one. Let me know if anyone has any questions. I'm just trying to figure out, like, this first variable. I don't know whether it's better to just do this, honestly. Like, we don't really need a first variable. We need a key variable. That's the most important variable that we need. So we'll just call it like current key, current key. Like that. That's probably a better way to write it. So a slightly different way to implement this that lets you just iterate all the way through words without having to skip the first one is we have to start the answer at empty list, and we start the current key off at -1. So then we get the key of S. If the key is not equal to the current key, we update it. And we put S in the answer. Does this work too? Yeah, that works too. This might be a little cleaner because you don't have to like handle the first word. You don't basically, like, you're not special casing like the first element of the input. You just start off your key at something that cannot possibly be a key. So I'm just choosing -1. You could do none, you could do false, you do whatever you want here. Maybe none is better to represent in the code that there's no key when you're starting. Then you go through all the words one at a time, you grab its key, If it's not equal to the current key, you update the current key and you put the answer in S. Wait. My music player app is trolling me right now because I have instrumental music selected, like I have it selected to only play instrumental music, which this song is not. So we'll just skip. Okay, so that's enough of this one. I like this one. I like this problem. A cool little thing is how it forces you to make a key out of the string, where all the strings that are anagrams of each other will have the same string once you sort their letters. If you wanted to, you could. Your key doesn't need to be a string of sorted letters. Like, that's probably a way. That's the easiest, right? That's the easiest key. You could probably write a function, like a hash function, to generate a unique integer, but 26 times to the nth power. That would be like the range that your key would need to support. Okay, so that's enough of that problem. Okay, so we've solved 2 anagram problems. What was this one? Palindrome permutation. Given a string S, return true if a permutation of the string could form a palindrome. Okay, so this is one that we can use counter for. So the intuition for this that you need to observe is interesting. So a palindrome, in order for a string to be, for it to be possible for a string to be permuted into a palindrome, you can only have one of the letters of the string appear an odd number of times, and every other letter that occurs in the string has to occur an even number of times. So let's use counter again. We can just throw in a Python counter for this, and it'll help us solve the problem a little bit faster. So from collections, import counter. This is kind of what I wanted to have happen. I wanted to find another problem where you can just throw in a counter and it makes it easier. Oh, Tarsky operator, thank you for following the stream 2 minutes ago. Really appreciate that. You're helping me along the way to my follower goal of 5 for the day, which probably won't happen, but you know, any positive number of followers for the stream is an improvement. So Tarsky operator, you ask, are you allowed to just import whatever? I think I understand your question. Let me know if I don't, but I can't just import whatever. Since I'm writing this program in Python 3, the things that I'm allowed to import are all of the things that are implemented in the Python 3 standard library. So if I just search for that, so I just searched for Python 3 standard library and it came up. And so basically what this page is, I assume, is an exhaustive list of all the things that you're allowed to import. This problem is premium. Is it? Oh, how do I see? It might be. It might be. My apologies if I chose a premium problem that you can't see. Hold on. I realized I didn't post a link to the current problem in the chat, but that's not very useful if no non-premium people can't see it. But yeah, so I'm importing something called counter, which is it's basically something that's just implemented by Python. If you see here, I'm on the Python standard library, and there's a link here to all the collections. So if I click that, now it's showing me all of the things that can be imported from collections, and the one that I'm using here is the counter. Yeah, there's a lot, but there's a lot of stuff. There's a lot of stuff in the Python standard library that you can import. In the case of solving LeetCode problems, they offer a lot of like important data structures and algorithms kind of like implemented out of the box. So if you know where to import it from, you gotta like you got to be able to like look it up or already have it memorized, and that can save you a lot of time when you're solving these problems. Same thing for C++, and probably some of the other languages supported here. But C++ and Python 3, which are languages that I'm familiar with, both have a massive, massive standard library of stuff that you can just import. So hope that answers the question. So the next thing to do is to create a counter out of S. So like that. And so now what we need to do is we just need to check that only at most one of the letters in the counter can appear an odd number of times in the word. So let's just create a Boolean. So basically we'll make a Boolean that represents whether or not we've seen a letter that appears an odd number of times yet. So seen odd letter, and we'll start it off with false. And so now let's iterate through all of the letters in the counter. So for a letter in C, this part's pretty straightforward. If it's odd, if it's even, we can just skip over it. We don't care because that's fine. We just want to see if it's odd. So if if the number, so C letter right here will give me the number of instances of that letter in the input. So if I can divide that by 2 and get 1 as a remainder, this is a simple just checking if something's odd in Python and many other languages. You do it the same way. So if it's odd, then I want to set seen odd letter to true. But importantly, if I've already seen an odd letter, then we actually have finished, we've solved the problem. So if we've already seen an odd letter when we get here, if we've already seen an odd letter, what we can do is return false. So this function is supposed to return true if there's a permutation of the letters that forms a palindrome. Otherwise, it returns false. So if we've seen an odd letter, we just return false. Otherwise, because we just saw an odd letter, we'll set it to true. And then we just let that go all the way through all the letters. And if we get to the bottom and we haven't seen 2 instances of an odd letter, we can return true, meaning we're good. This string can form a palindrome. Okay, so let's use the example test cases and run the code on those. Okay, so for the 3 examples, we get the expected answer. So it is important to note that that if you were to do a more brute forced, you could have 1 odd letter. Yeah, exactly. So you kind of have 1 odd letter, and that's why I'm keeping track of whether or not I've seen an odd letter. So if I'm iterating through these letter frequencies and I find a letter that appears an odd number of times, then if I've already seen an odd letter, yeah, okay, you see it now. So this is structured so that only 1 odd letter is allowed. And then you already figured this out, but then, you know, for the palindrome, that letter would have to appear in the middle is how that would work. So I think this is right. Let's look at the hints. Consider palindromes of odd versus even length. Yep. Count the frequency of each character. We got that. I know you can't really see the hints because of where my face is, but yeah, okay. So this is an easy problem. Let's just go ahead and submit it. We get it right. It's also pretty fast. I imagine that solutions that just depend on Python's so that wasn't for you. After I solve a problem, or sometimes if I'm solving a problem and I get stuck, I just open up the hints. Oh, thanks. Masters, I disagree with that. That was an easy problem. So there's plenty of problems on LeetCode that are marked some medium, some hard, that take me a lot more energy and brain power to get. So anyway, it is pretty fast though. We got faster than 84%, better memory footprint than 96%. So that's that one. Okay, so let's take a look at this problem. This is just another problem that I selected for the stream before I went live. And let's see what it's about. So an integer, so this is problem, I don't know if this is a premium problem or not. So I see for the premium problems, I think there's a website where non-premium users can see them. I don't know if I should be promoting that on the stream. Okay, cool. It's not premium. That's good. I probably shouldn't encourage people to use it, but I think there's like a mirror version of LeetCode that you can go to where you can see where you can see the premium problems even if you don't have it. The only downside is that you can't like submit, you know, and have it affect your stats in the actual version of LeetCode. So you got enough problems? Cool. Yeah, that's life. Life has a lot of problems in it. LeetCode has a lot of problems. An integer has sequential digits if and only if each digit in the number is one more than the previous. Return a sorted list of all the integers in the range low to high, inclusive, that have sequential digits. So if you get low of 100 and you get high of 300, the answer should be 1, 2, 3, 2, 3, 4. If you get low of 1,000 and a high of 13,000, the answer should be 1, 2, 3, 4, 2, 3, 4, 5. Interesting. It doesn't seem too hard. It's kind of like this seems like what's the word? Like I think you can just cleverly like iterate through all the possibilities and generate them and just add them to the answer one at a time. So for example, for 1,000, you'd be able to see pretty easily what the next so you'd be able to see pretty easily if you're at so you're basically gonna like start at so int current equals low, right? And while current, let's see, this is just like kind of pseudo code even though it's not. While current is less than or equal to high, and then you're gonna have an answer vector of int answer, and down here you'll return the answer after building it, something like this. But now the thing now is let's look at the size of low and high. So according to the constraints of the problem, low is at least 10 and high is at most 1 billion. And so I think because that's the case, the correct answer is not going to include plus current here. I don't think that they want you to look at every single possible number in the range low to high and check to see if it's something that should be in the answer. Instead, they want you to intelligently jump from one to the next. So for example, so if we look at this, if we just look at this first example, right, we're starting at 100, and then it's pretty easy to see based on the requirements of, like based on the description of the problem, it's pretty easy to see that 1, 2, 3, 4 is next, without having to go like 101, 102, 103, you know, one at a time. You just know that you take the first digit and then the next digit is one higher than it, so it becomes 1, 2, and then you know the next digit is one higher than that, so 1, 2, 3. The only other thing though is we do have this thing where we probably need to convert between strings and we might not need to do that. I think I am gonna convert between strings and integers to solve this, and because I'm doing that, I think I'm just gonna switch over to Python again to solve this one, and I'll use C++ for a different problem. So we got our answer is an empty array that we return. And then while low is less than or equal to high, we'll just go. So the first thing we want to do is check to see if low meets the requirements. So let's do low stir is going to be the string version of low. Low stir is the string version of low, and now we just iterate through it to see if it's good. So let's do it this way. So is valid equals true. Valid being that the number low should go into the answers array. And so now we're going to iterate through the string and check to see if that's actually the case. So for every character in low stir, and so let's do it this way. Let's skip the first one. So we can go like that. And now what we can do is, oh no, there's like a smart Python-y way to like look at consecutive pairs of a list. So let's just Google how to do that. So Python for loop consecutive pairs. I think it uses the zip function. Iterate over all pairs of consecutive items. Yeah, here it is. So let's just copy paste from Stack Overflow because, you know, that's what we do sometimes. So if you zip low stir, if you zip, hold on, how about we call this S, is just the current string that we're looking at. So if we zip S with S1 colon, we should get, and we'll call this A and B. If the int value of A is not equal to the int value of B minus 1, then is valid as false. So basically, yeah, it needs to go. It needs to be like 1, 2, 3, 4. So I think that's right. So then, as soon as we discover that it's not valid, we can just break. Oh, RS_GGS, thank you for the follow. Sweeter Kev, thank you for the follow. Really appreciate you guys stopping by the stream and helping me on my daily follower goal to 5. So thank you for getting me to 3 out of 5. Really appreciate it. I assume because you joined the stream and you followed that there's something about what I'm doing here that you either find entertaining or valuable. And honestly, I'm fine with both of those. If you're laughing, good for you. You laugh away. If you find this educational, great. but for whatever reason you followed for, I appreciate it. And you know, the chat's an open, safe space. So if you feel like being active in the chat, you're more than welcome to. But also, there's no pressure to. RSGGs. Just started the coding interview grind. Gotcha. Well, best of luck. I'm familiar with the grind. And Sweeter Kev, nice to see someone else's thought process. Yeah, I agree. So I think what I'm gonna do, just to make sure that some of this code is right, is I am gonna do ++ low. But that's not gonna be part of my final solution though, because I think that I'm pretty sure what you're supposed to do is just jump to the next number and not look at them all one at a time. But let's do this though. So if we iterate through it and we discover that the number is indeed valid, then we want to put it in our answer. So we just have answer.append the int version. Oh no, we just have answer.append low. Importantly, the answer is supposed to be the actual integers and not the string representation of it. Okay, so what happens when we run this code on the small test case? Judging is taking a while. Is this TLE? Do I have an infinite loop in here? The answer is yes and probably yes. So oh, you can't do ++ low in Python. I always forget that. I think the shortest way to increment a number in Python is to use += 1. I also solve a bunch of these problems with JavaScript and C++, and so you know, can obviously use ++ in those languages, but not in Python. Okay, so that didn't quite work. Let's try to figure out why that didn't work. So we turn low into a string. We say valid is true. So obviously this zip is not working. Hey, you're right. Thank you. I'm sure that I would have gotten there, but you sped up the process of getting there. So okay, let's run the code again. Okay, yeah, that works. Yeah, Tarski operator and Sweeter Kev, thanks for pointing that out. So we do have to return the answer. So that works. I bet that this will also be pretty quick for this test case. Okay. Now the question is, here's the question. Should I submit this and get the time limit exceeded just to make sure that I actually do need to do the next step, or should I just do the next step right now? Let's see, how hard is it to get from okay, so what we need to do is we need to make low go to the next thing. And so the other thing that's important to keep in mind is we only really, if we're always increasing low to the next YOLO. If we're always increasing low to the next thing that needs to be in the array, then this check only actually has to happen for the first low, the first value of low. I kind of agree about YOLOing it, to be honest, but how hard would it be to make low go to the next low? So let's say that we're at 1, 2, 3. So we have 1, 2, 3, and we need to go to 2, 3, 4. So that's pretty simple. 1, 2, 3 to 2, 3, 4. We're basically just incrementing it's the same length, 3 digits long, and we're just going to every single digit goes up 1. But that doesn't work for like the first number. Like for example, 100 also needs to go to 123. So Really, a better way to think about it is just that, you know, like after the first digit, they're all just one more than the previous. But in this case, the first digit needs to increase. In this case, the first digit doesn't need to increase. And then also interestingly, in the case where the input spans multiple powers of 10, so if, like in this example 2, we have numbers in the thousands and we have numbers in the 10,000s, we need to handle that. So as an example, we would need to be able to get from 789, which would be a valid answer, and we need to be able to get from that to, is the next one 1, 2, 3, 4? Is that the next one? Yeah, that looks right. So that looks right based on this. Notice how they're going from an answer that's 4 digits long to an answer that's 5 digits long, and so 6, 7, 8, 9 needs to become 1, 2, 3, 4, 5. But yeah, let's YOLO it just for fun, and even if I get accepted, I'll come back and I'll implement this just because it is interesting. So I just clicked run code. Why is it taking so long to judge suddenly? What did I break? I broke low plus equals 1. Okay. Good thing I didn't hit submit. Okay, so let's submit. It's not gonna work. I'm like 99% sure it's not gonna work. It seems like it's TLEing based on how long this is taking. Okay, it certainly does. It TLEs on the largest possible test case, which is 10 and 1 billion. Let's add that to our test cases, and we'll make it pass for that now. So I think this is an interesting way to approach the problem. So I think the very first thing I'm gonna do is get the value of low to be equal to the first answer. So if is valid, break, then if is valid, break, and then low plus equals 1. So my idea right now is I'm gonna have a dedicated while loop at the start of my function that gets low to the first thing. Because then after that, I no longer need to do this check every time. All I need to do is write some logic that goes from low to the next value that should be in the answer. So now we're gonna have another low is less than or equal to high. And in this one, we're only dealing with numbers that should be in the answer. So every single time this loop runs, let's just append low to the answer. Right? That's my idea. So increase low. Although we also don't need to do it this way. Like, we don't need to do this thing where we're incrementing low one at a time. We can take the current value of low and change it to be the first valid value. Hold on, what happened to those comments? I like those. Yeah, I like being able to see this so that it kind of gives me an idea of what I'm doing. Is there any math tricks to get all the numbers? So I think there is. Yeah, I think there is. I'm glad you asked that. because these right here, the difference is 111. And that's going to be the same for like all of them except for the last one. So like 2, 3, 4 to 3, 4, 5. The difference is 111. But then this one is an exception. What is that? Hold on. I don't know if I don't know if the difference of these two matters. Because we probably just have to treat this as a special case. So the difference between those is 445, which probably doesn't matter. So obviously the difference between these is 23. And then the difference between these is 445. But in general, like for the normal case, I think we can just add like you know, just add a bunch of ones to it. Make a number by concatenating a bunch of ones and add that to it, and that will get us to the next one. What about this case, which is in example number 2? 6, 7, 8, 9 goes to 1, 2, 3, 4, 5. I highly doubt, let's just check it though. Does the difference between those two numbers mean anything? 5, 5, okay. So it looks like there is a pattern there too. There is a pattern there too. I don't know if it's worth trying to code that pattern. Like you can see that we went from 445 to 5556. So interestingly, this is equal to 111 times 4 plus 1. And this is equal to 1111 times 5 plus 1. So maybe we could do that. I don't know if that's the easiest way, but I feel like that'll work. The times 4 and the times 5 would be like representing what the new length of the number is. That might be fun to try to do it that way. I think I'm going to code it up that way. That seems like fun to me to code it that way. Also, if we code it this way, our like main for loop where we're generating the answer, we probably need to do minimal like integer to string conversions. We would need to do something like here. Let's make a util function. Get get all ones int, and we would have a size which would be the number of ones in it, and then it would be return int, and we would cast an int from a string, and the string is going to come from multiplying the string 1 together size times. And so, for example, let me comment some of this code out. Some of this I'm going to keep, some of this will change. This is a really fun exploration though. Let's just print get all ones int of size 5. Yeah, so that works. And then we could do like, so that's going to be that. So this this util function will just help us generate like these numbers here. 111,111. It'll help us generate 445, which is 111 times 4 plus 1. Okay, so I'm glad that there's some people watching that seem to be pretty engaged. I need to take a quick restroom break for a minute. I'll come back and I'll solve this problem, and once we've solved it, the next thing is I'm going to try some of these dynamic programming problems suggested by the Dynamic Programming 1 study plan within LeetCode. But yeah, so just give me a minute and I'll be right back, and then we'll keep going. Okay. Brief interlude over. I did think of one more thing I want to do. I highly doubt it's going to make a huge difference in this specific problem, but what we can actually do here is we can memoize this. And so in Python, Python functools cache. So in Python, you can actually just decorate a function with, I think, yeah, you can just do like @cache. And basically it memoizes all the function calls for you. So I think I'm going to do that. So from functools, you can also use this for DP. So I think I can just do @cache here, and let's run the code again. Yeah. So the idea is that whenever I call this function with a value that's I've previously called it with, it won't have to redo this computation, which granted is not, it's not particularly expensive, but if it were, it wouldn't have to redo it, and it would just return the previously generated value that the function produced. Okay, so let's actually try to get this accepted now. So the first thing we need to do is take the first value and get to the first valid value. And we could just do it this way. No, but that's slow. That's slow. So the first valid value is going to be. So okay, let's. I think what we can do here is actually just assume that the first value is invalid. So we're gonna make low valid. That's what we're gonna do. Even if it is already. So so the first character is going to be, so let's get our low string. Let's get our low string, and we'll get our first character. So the first character is s sub 0. Let's turn it into an integer. And then now let's make a new s. Start it off at empty string. And let's go for I in range length of the original s. And new s plus equals, how about this? Prev. Plus equals prev. And then prev plus equals 1. Print prev. Print new s. Oh, that, yeah, you can do just a unary plus in other languages, but in Python you gotta use int as a thing to convert. Okay, and then I need to do the same thing here. Okay, so the good news is this works. For our sample test cases, if I run this code, so the input is 100 as the first low, 1000 as the second low, and 10 as the last low. So you can see that our code is generating the first valid low. So once we have that, let's do this. Low equals int new s. So what about if the low is, let's create a new test case that I don't think this is going to work for. For example, this is not going to work for 900, right? Let's say that we were going from 900 to 1000, which actually is an interesting test case because between 900 and 1000 inclusive, there's no valid answers. So that's a decent test case. But what I'm trying to do right now though is demonstrate that the program doesn't generate the correct low value for 900 because it's going to try to do 9, 10, 11. So we're going to get like a number in the 90,000s. So if we run that, oh, I'm not printing the low anymore. Print low. Yeah, so it created 9, 10, 11. So that doesn't work, and we need to handle that case. So basically we need to detect when this right here overflows. Oh, okay, here's if prev is greater than 9, then we've already like overflowed what works. This feels like really ad hoc code, but let's just say works is true, and if it doesn't work, then we'll set works equal to false here, and we'll have to handle that case specifically. So if it does work, then low is this. If it doesn't work, then we need to go up to the next power of 10, right? So let's say that we had 900. The next valid value of low is 1, 2, 3, 4. So let's try to generate that. Low equals, let's see. Let's see. This might be a little nifty here. I might try to do something fancy. Int of empty string dot join, and then a list comprehension, where it's I for I in range 1, and then the length of S, right? S being our string version of low, plus 1. What happened there? Sequence item 0, expected stir instance, int found. Was wrong. Low equals int. We got empty string dot join, and then we have a list comprehension. I for I in range. Whoa, is that not right? So this produces a list. Can I just print this real quick? Oh, you know what? I could be using the debugger. Let's do that if this doesn't help. So let's just print that. Oh, and this is in the wrong place. I need to check this first. I don't think that's what's causing this though. What I'm curious about is why we're getting 1, 2, 3 here. Although it does look right though. 1, 2, 3 as an array does look right for this. Oh, and also it's len of s plus 2. Right, because we're trying to get 1, 2, 3, 4 out. So the list comprehension is working because I'm able to print it and we're getting 1, 2, 3, 4. What's not working is joining that into a string and then converting it into an int. Which I thought this code here would just do. Why is that not working? Python list join. Yeah, okay, so you can do string.join list, which is what I'm doing. Also, something that's going to be interesting to think about now is like, now that I wrote this list comprehension and this is able to give us a valid answer, maybe we just want to reuse that down here instead of using the one, but let's worry about that later. Which part of this is not working? Is it the converting it to an int that's not working? Oh, I see what it is. I see. So this part's actually fine. When you call string.join, it expects the list that you're passing it to have all strings. So we need to convert this I to a string. I think that this is what it is. There we go. There we go. There we go. Okay. So now I think we're good actually. So our code is, the very first thing it does is it tries to turn, well, it doesn't try, it appears to successfully turn the first value of low that you get into the first value that should go in the array. So now that we have that, let's get rid of all this code because I don't think I need it. Let's get rid of that. We don't have to print low now. Okay, next, generate the answer starting from the first valid low. that we just generated. Also, it's important to note that, oh, actually, I haven't even tested this, but I assume that if I were to start off low as like 123, the number that it generates should also just be 123. So let's have this as its own test case, 123 through 234, in which case the answer should just contain those two. Okay, so now we're going to use this information. We don't care about this case though, because that's what we just did. I could use that as an example of what this does. So this makes 100 go to 123, it makes 123 go to 123, and it makes 900 go to 1234. So we've done that. In the case of like an interview or something, it would probably make sense to like pull these lines of code out into their own function. I don't think I'm gonna bother with that right now. So let's do this. So the second part of the solution is these things. So going from 1, 2, 3 to 2, 3, 4, so on and so forth, and also being able to go up to the next power of 10 when necessary. So this part is going to be while low is less than or equal to high, right? And the first thing we do is we're just going to put low in the answer. So answer.append low. And this is nice because let's say that this code runs and it increases low to the first valid low. It is possible that low is now actually greater than high. And if that's the case, the while loop just won't run, and we'll never put that in the answer. RSGGs, any reason why you're interview prepping or just practicing for fun and refresh? I wish I was practicing for fun, but I'm actually in the job market right now, so I'm actually prepping for interviews that I have coming up. How about you guys out there? Are you prepping for interviews actively, or are you browsing the software gaming development on Twitch for fun? Curious to know where everyone's at and where everyone's coming from. Okay, so now we've taken low and we've put it in the answer. The next part is to jump from low to the next one. So we're still gonna turn it into a string because really what I want to see is if the last number in low is a 9. If s sub -1 is a 9, then we're gonna do something different than when it's not. Oh, wait, no. Yes. Because if the last element is not a 9, then we can increase low without having to go up to the next power of 10. Sweeter Kev you're in the market as well. Cool. And RSGG's, similar reason, 2.5 years in my company, and now I'm trying to change companies. Got it. And then Boca Joe. 12 years in my current job with no end in sight. Enjoy watching dev streams and helping out when I can. Awesome. It's good to have you in here, Joe. Thanks for hopping in the chat. As you can see, I'm just chilling, solving some LeetCode. But yeah, for those of you out there that are also actively prepping for interviews or trying to make a change, yeah, good luck. I've done this grind before, and it can be fun, but it can also be stressful, and it can also be frustrating. You know, you open that problem up that you feel like you should be able to do, and you know you're getting wrong answers out or time limit. So to reference variable names in the solution to this problem, you know, the grind has its highs and lows. But I'm glad you guys are here. hopefully you're finding it engaging. I don't want to spend too much longer on this problem because there's other problems that I'd like to get to. So if the last element of this string is a 9, then we need to do this. So low plus equals get all ones int. Get all ones int. What length do we need it to have? So if we're going from a length of 3 to a length of 4, we need it to have a length of whatever the length of low is, of s is. That's the number of ones that we want to have, and we want to multiply that by one more. So let's do this. S equals stir, and then we'll have like current length equals the length of the string. So if it ends in a 9, then we get a number containing only ones of length, current length, and we multiply it by I think this is going to work, although it might not be the most readable solution. We multiply it by the current length plus 1, and then we add 1. I think that that's going to work. And then otherwise, if it doesn't end in a 1, then low gets increased by this. Is that right? How do you guys feel about that? I'm going to run it on the sample cases and see what we get. Okay, so this does work for the test cases that we've tested it on. So Sweeter Kev, yeah, it can be demoralizing at times, but we all go through it, yeah, for sure. Yeah, okay, so that looks good. All right, let's try to submit this. Okay, so we got wrong answer, unfortunately, for this test case. So let's see what that's about. Have you guys, and/or girls, and/or however you prefer to be referred to, have you all been looking at any interesting LeetCode problems recently? If there's like a really interesting, fun one you found, I'm curious. I'd like to take a look at it. There's a lot of problems on the website, so sometimes it can be hard to find like really, really good ones. Okay, so let's isolate this test case, 58 through 155, and see what's happening. Oh, duh. There's a bug with with these lines of code. Okay, I see. So we're supposed to be starting at 58, but because of how I wrote this chunk, my first low that I'm looking at is 56. Okay, so basically, LeetCode 423. I'll take a peek at it. Not now, because I'm going to finish this one, but let's at least see. Reconstruct original digits from English. Given a string S containing an out-of-order representation of digits, return the digits in ascending order. Huh. Really? So this jumbled mess here contains the strings 1, 0, 1, 2. And then this jumbled mess here is it's actually slightly easier to read. Contains 4 and 5. I don't think I've done this one. Yeah, I don't have any submissions for this. Okay, I might come back and look at that. I gotta fix this first though. Hopefully this won't be too annoying to do. I think everything else is right in the solution, but we gotta make sure that we're getting to the first valid low value properly. Oh, okay. So, so I'm not supposed to be thinking about this yet, but if you create, you basically define all the strings, right? You define all the strings of the digits of the English language. So you have like an array or something like that that just has the strings 0 to 9. And then is this a graph problem? So you've got O, right? You start off with O, and so that could be in 1 or 0. So I'm just trying to think about this. So let's say that you're iterating through these letters one at a time, and you want to, so you're at a current letter and you want to check to see which English digits it's in. So you need to be able to look up that easily. That's not too hard to do. You can make like a hash map from the letter to the numbers that it's in, to the digits that it's in. And then I think, is this a backtracking problem? Like, do you try all those, right? Like, so you're at an O, and you're like, okay, so O can be in 1, O can be in 0, O can be in 4. Is that it? 1, 0, and 4. No, 2. Okay, so you have like O can be in 0, 1, 2, 4, and so you try each of those one at a time, and then you have kind of like some sort of a backtracking algorithm that might work. So I'd probably come back. That's the idea. Okay, backtracking is fun actually, so I might actually want to code that just because I enjoy writing backtracking problems. I solved LeetCode Sudoku solver recently. So I solved this one. So this one is a fairly straightforward backtracking algorithm. Oh, here's my code right here. So I'd probably use a similar approach when approaching the Reconstruct original digits from English. That's funny. That's funny. They just throw you a jumbled mess and they're like, make numbers out of this. Okay. So the problem here is that I'd start with the first digit and I go to 56, but the problem is that when I generate the 6, it needs to be greater than, it can't be less than what's already there, right? So if I've got a 5, 8, and so then I go from 5 and I say, well, then we want the next one to be 6. It can't be 6 because it needs to be greater than what's already there, not less than what's already there. Even simpler than backtracking, but could see that working. Oh, okay, there's an easier way than backtracking. Also, you said you're going to head to bed, though. Good luck on the grind. Thanks. Appreciate it. Thanks for stopping in. And also, thanks for the follow. Appreciate that. I'm doing these streams fairly frequently. So far it's been once a day, although the problem is the timing hasn't been very consistent, so I don't really want to say what time to expect me, but I am going live to do this every day at the moment, so I hope you come back. But yeah, have a good night. Thanks for stopping in. So is there an easier way to generate the first low than what I'm doing? Okay, so let's think about it this way. If we have a number like 58, also let's put 58 here in these comments, because it's not really represented yet. So 58 should become 67. So it's either gonna be, my current code produces 56 from this. It's either that or it's 67, or it's yeah. I think I see how we can do this. I think I see how we can do this. So if this fails, so we can run the code as it is now. If this fails, so if we get to the bottom of these like whatever, like 20 lines of code, we can tell that it failed because the number that we generate will be less than the original number. If it's equal to, that's fine. So we get down here. If low, so we actually need to keep track of our original low. Original low equals low. And so if we get to the bottom and the low that we produced is less than the original low, then we simply need to run the exact code again, but with 1 digit higher at the beginning. Is that the easiest way to just fix this real quick? Like, so at this point in this problem, I'm kind of in like get it accepted mode in my brain. I'm not really in the mode anymore of what's the most beautiful way to write this. So let's just see. Is that all I need to do? So if the new low we generate is less than the original low, as would be the case with getting 56 from 58, then we need to run these lines of code again. For now, so don't ever do this in your own code. I'm just trying to confirm that this is the answer. Hey, what's up, Xproof? Yeah, you can consider me a LeetCode streamer, at least for now. I don't plan to be streaming LeetCode every single stream for the rest of my life that I'm doing streams in, but like I want to get to the point where I have a new job and I can stream like just development, the like writing software, probably for the web, like React and stuff like that. That's what I usually like to do in like side projects and stuff. But right now I'm actually on the job market. I'm on the interview prep grind. So yeah, I'm streaming LeetCode. How about you? Do you stream? Do you stream LeetCode? Let me know. And also, yeah, don't do this in your own code. I'm just trying to see if this is the problem. So so here's what I'm gonna do. So if it didn't work, we'll reset low to the original low. Oh, cool. Yeah, there's I've seen some LeetCode streams. Every once in a while, big names in the competitive programming world will go live. Like if you get I can't even remember his name now. Like Alex Weiss, or I can't remember. I'm drawing a blank on names now, but people who are like extremely experienced in CP and like compete in big contests and shit and win. Yeah, don't expect anything like that out of my LeetCode streams. I'm way less skilled at LeetCoding than they are. I was grinding, but I guess I'm still grinding, but not for a job. Nice. Just to get better and make sure I'm good if I get an opportunity. I was interviewing for Google 2 weeks ago. Nice, dude. How did it go? How did your interviews with Google go? Are you still waiting to hear back? Like, did you pass into the team matching phase of the process? I worked for Google for 1.5 years, and then I actually quit 1.5 months ago to 2 months ago, and I've just kind of been chilling. I wanted to be unemployed for a bit, focus on some other areas of life, but now for financial reasons and other, I'm back on the job market. But not trying to go back to Google. But Google is an excellent company. So I just saw that you said you're in the team matching phase. Congrats. That's so cool. I hope you find a really good team on a project that's really fun to work on. Okay, RSGG's. You heard that Google and many companies have a hiring freeze right now. Not to worry anyone. Oh, that's interesting. I didn't come across that piece of news personally, but yeah, I guess that might be something that's happening right now. Yeah. And then you said you did very well. The signals were positive, and you're in team matching. Oh well, you're good. I don't think that they're gonna take you out of team matching. They'll just, like you said, they'll just have you on pause till they're ready to hire more people, and then you should be able to just pick up where you left off. That is kind of annoying though, so I'm sorry that you got through all of that and then they put it on pause. That is annoying, but at the same time, just getting through the interviews to team matching is an impressive feat. So, congrats on that. Low is original low. Okay, then here's what I'm gonna do. I'm gonna do this. So S0 equals stir of int of S0 plus 1. My friend got through to team matching, but they said they can't do anything. But if your recruiter says anything, your application is valid for a year. Oh, okay. Yeah, that's all really good information. So, RSGGs, your friend got through to team matching, but they're absolutely not getting a job because of the hiring freeze, or they're just on pause too? Let me just Google this real quick. If there's like a massive hiring freeze, like just in the industry in general, I haven't heard anything about it, but okay, let's see here. TechCrunch has an article from 1 day ago. Wait, what? It's just a headline and no article? Okay, here we go. Google has announced they'll take a 2-week hiring freeze, according to an article. This comes after the company announced last week they would slow down their hiring process for the remainder of the year to take a fresh look at their overall hiring process. Okay. The company has reportedly hired close to 10,000 people in Q2 alone, which is a fucking shitload, with full quarter results set to drop on July 26th. We'll use this time to review our headcount needs and align on a new set of prioritized staffing requests. Prabhakar Raghavan. I used to indirectly report to that guy. He's trying to remember what area of Google he's over, but I was working on search, and if you followed down the tree from him, he was ultimately some kind of like president or something over search and some other like areas of Google as well. Similarly, Twitter initially issued a hiring freeze, then laid off 30% of its talent acquisition team. Damn. Yeah, that is stressful for people who are looking for jobs, but hopefully that stuff irons out soon. In the meantime, I think all we can do is keep grinding. Hey, what's up? Graham613. I had a Google interview scheduled this Wednesday and they moved it to next Friday because of business conflict. I'm surprised they gave me a new one so soon. Well, congrats on getting the interview. And yeah, kind of like you pointed out, better to get rescheduled than put on hold permanently. So that's a good sign that you still have the interview coming up. I missed a bunch of messages, although I am glad that you guys are talking amongst yourselves. Okay, so mid-level and senior, okay. Entry level, not good. Yeah. That's rough, especially if it's because they're predicting a recession. Damn, that's kind of a letdown. That's a bummer, but yeah, all we can do is just keep grinding out, you know, for the interview prep, and eventually, you know, even if it's not at, you know, Google or Amazon, finding a new job at a company that's prepared to hire people. Okay, I'm trying to wrap up this problem, so okay, this might work. Fix a couple of syntax errors. Okay, so we'll convert it to a list first, and then we'll set index 0 equal to, we're just trying to increment it by 1. Equals the string version. Here, it's this. We need that. And then we'll bring it back into string form this way. And then that should work. Like this. Okay. All right, so we got test case passing for 58 through 155. I'm going to bring back all of the test cases that I've been testing against, and let's see how we do. Okay, those all pass, submit. Okay, there it is. So I had a couple of little issues with the way I was going from the lower bound and jumping from it to the first valid solution, the first valid thing that needs to go and answer. And honestly, it's kind of annoying. There's a bunch of edge cases. What I came up with is all this. This is kind of an ugly mess, but it does work. But in my opinion, the more interesting part of the program is jumping from one of the elements of the answer to the next, right? So you've already figured out like that you're at 123 or 234 or something like that. And now just jumping from those to the next ones one at a time. So I'm very happy with this part of the solution. I am not at all happy with this part of the solution, but I've also been working on this problem long enough that I don't really care about it anymore. And there's other problems that I'd like to look at. So that's all I'm gonna do for LeetCode 1291 sequential digits. One last thing that I will do though. Is just take a look at this the solution doc, because it is a premium solution. Oh, pardon me. And let's just see what they suggest. Maybe there's something genius in here that we didn't think of. One might notice, okay, so sliding window. One might notice that all integers have sequential digits or substrings of the string. Ooh, okay, that's interesting. Yeah. So every single string or number that you could possibly print as an answer is a substring of this. Hence, to generate all such integers of a given length, let's just move the window of that length along the 1, 2, 3, 4, 5, 6, 7, 8, 9 string. The advantage of this method is that it will generate the integers that are already, yeah, in sorted order. Yep. Okay, so the code looks pretty short. That's cool. Okay, so let's see how some of these solutions work. Oh my word, look at that. 01 time? I don't think mine runs in 01 time. So you get the length of the lower bound, you get the length of the upper bound. And you've got your, this is the answer. You're just generating an empty array list. Then you got code that adds to it, and then you return it. And you've got your string 1 to 9, and you've got n, which still trying to figure out what n is. So you iterate. So you start your length off at low length. And then you iterate till you're less than or equal to high length, which is the same as less than high length plus 1. And you increase the length. So, okay, so that makes sense. So basically, if your low integer has length 5 and your high integer has length 7, you already know that the integers in your answer are going to have length 5 and then length 6 and then length 7. So that's all the outer for loop does. Then the inner for loop, start 0, start is less than n minus length. Oh, okay, so it's talking about where we're starting in here. Yeah. Then you create your number, so integer.parseInt, and you take the sample and you just pull a substring out of it from start to the length. And then last but not least, this is actually, this right here is similar to something I did in my code, which is like you generate, whenever you generate like an integer that would be valid to go in your answers array. In other words, you generate a substring of 1 through 9. You just do this kind of like last check here to make sure that it's actually in the bounds of what you're supposed to be doing. And then you throw it in there. And so they claim the time complexity is constant. Length of sample string is 9, and lengths of low and high are between 2 and 9. Hence, nested loops are executed no more than 8 times 8, which is 64 times. Okay. Either way, yeah, so that's just a fancy way of saying it's lightning fast. And 01 space to keep not more than 36 integers with sequential digits. Oh, okay. So they basically just figured out that there's at most 36 like of this there's at most like 36 substrings of this, I think is what they're saying. Is that right? That seems right. Okay, let's take a look at approach 2. So actually there are 36 integers with the sequential. Ooh, okay, so in this approach they recognize that there's a very limited number of answers, and so they just generate them. And then they iterate through them, and the ones that are between low and high inclusive just go in the answer. So yeah, let's see. So we got our sample, we've got our n. We iterate through substrings of increasing length, and then we just decide where we're starting, right? We're just going to iterate all the way through all the possible starting points. They generate an integer and they add it to nums. So once the constructor of this class is done running, nums has all 36 of the integers that are valid, substrings of this integer. Then, since there's only 36 possibilities, when you call the function and you give it low and high, you just go through all the nums, and the ones that are between low and high, you just put in the output. So yeah, that's pretty cool. And so this is also constant time, both for pre-computation and during runtime. Blah, 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 blah. And then constant space. because they're keeping exactly 36 integers that have sequential digits. Okay, so the very first comment, this is kind of how I feel. I don't feel quite like this because I did get it accepted, but I feel kind of like that because of how this section of my solution looks. Yeah, and then sliding window technique. So that's pretty cool. So there's different ways to approach it. I like the thing that I like the most about these solutions here is the very important factor of being able to look at the description of the problem and observe that the size of your possible answers is extremely small. So as soon as you take a step back from the problem description, right? You read the problem description, you go, oh, you think about it a little bit, you take a step back and you realize that every single possible answer is a substring of this string. That's a really important observation, because as soon as you realize that, you can take it one step further and be like, well, there's like only 36 substrings, which means there's only 36 possible answers. And then if you can get to the point where you've realized that the answer space is extremely small, then your solution becomes extremely simple. You just produce all of the possible answers, and then when they give you a low and a high, then you just go through all of the possible answers, and you only include the ones that are within the range. So that's cool. That's cool. I do like problems like that where you can like pre-calculate the answers. All right, so that was LeetCode 1291 sequential digits. So someone who was in the chat earlier, who I think has since left, suggested LeetCode 423. I'm not sure if I'm going to do this one right now because I've been live for 2 hours and 44 minutes. I don't think I'm going to be live an incredible amount longer. But before I stop the stream, I've already committed to at least taking a look at 1 or 2 dynamic programming problems. So I think the person who was in the chat earlier was saying that there's a more elegant and intuitive answer to this than backtracking. Because I'm pretty sure backtracking would work. What else could you do? How else could you do this? So the order of the letters obviously doesn't matter. We could sort these, and it wouldn't have any difference. It wouldn't have any impact on the solution to the problem. With the exception, of course, that sorting it incurs a cost of n log n time. But just based on the length of the input, I'm sure that's fine. You're getting a max length of 10 to the 5th. And you are guaranteed to be valid. You are guaranteed to be valid. So as far as the backtracking approach goes, yeah, I think you're right. As far as the backtracking approach goes, right? So if we turn this into a frequency table, so we could use a counter. I'm trying to decide if I want to solve this in Python again or switch languages. I think I've solved everything in Python so far, so it might be time to do something different. I might whip out C++ for this. Okay, so the first thing that we want to do is create a frequency table. So we want to be able to look up for every character. We want to look up how many times it exists in the input. So that's going to be an unordered map of int. Unordered map of type int. I usually call variables like this freak. And then for every character in the input, we'll increase the frequency of it. And so these two lines of code are basically identical to creating a counter in Python. So once we've got that, what we want to do is we want to have like some kind of data structure that keeps track of all the possibilities. How do I define like I want to define like an array literal. Is it an array literal? So I want something like this. O1, right? So I want a data structure that lets me look up for a specific digit. How many are like basically give me a frequency table for the letters that it needs. That's what I want to do. And it needs to be a frequency table because 7, for example, requires 2 E's. So I want to be able to make that. I want to be able to make it inline. So how do I want to define a C++. Is it possible to do like a... Can I do... Okay, let me see. I might know how to do this. So... I want a vector... No. I want a... Is unordered map literal a thing? C++ unordered map literal. Is that a thing that you can do? If you can't do it then I might just have to push everything into it manually. Initialize an unordered map through the initializer list. That looks pretty good. We want to do something like that. That looks pretty nice. Let's try to use that. So let's just paste that right there and use it as a guide. So what we want is a vector of these. So we want unordered map. We want an unordered map. No, we don't want an unordered map. Yeah, we do. We want an unordered map of char int. We want an unordered map of char int array. We want an array of those, and we'll call this digits. And then can I do this? And then can I put like this into each of them? Okay, let's just see if this works. So you have Z Z1 E1 R1 and then O1. Is this good? Is this allowed? That's what I want to know right now. Let's just return empty string for now. Unexpected unqualified ID. Oh, okay. Obviously, all of this is not code that I was planning to run. Brackets are not allowed here. Oh, okay. Oh, this is the most helpful C++ error message I think I've ever seen. Like, it literally told me what's wrong and how to fix it. So, according to the error message, I just have to move the brackets there. Okay, and what did I miss? It says char 10 expected. Do all these need to be, these all need to be in their own brackets, right? I promise I know C++. I'm just not used to declaring literals for fully initialized arrays of unordered maps. Okay, so is that right? It doesn't seem to like that. Char 11 Error expected at closing. What's wrong with this? This is what they're doing over here, right? Can anybody see what's wrong with this? Unordered map, chart to int array. Wait, do I need to have a 1 right there? Z1, E1, char 11. Let's see if there's any other examples that we can go from. Okay, so this looks like what we're doing. So you can create a map by having curly braces for the whole map, and then every single pair is in curly braces as well. Man, I don't want to spend too much longer on this minor detail. This is like not even the fun part of the solution. This is just necessary. Oh, I'm being dumb. Am I just being dumb? I'm just being dumb. So there's no colons here. Since these are pairs, there's just commas. I was just being dumb. Okay. Now what happens when we run this? Will the program compile? Yes. Okay, so the program compiles, which means I just need to generate this data structure for every single digit from 0 to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And so it's O, N, E. Then it's T, W, O. Then it's T, H, R, and then E has a 2. It's 2 E's. Then it's F, O. You know what? It might have been easier to just create like an array of the digit strings and then use that to build this in the code, but I'm already down this path now. So F, I, V, E, S, I, X, S, okay, S, E, but we got 2 E's, so we change that to a 2. Then V, then N, then E, I, G, H, T. Let me know if you catch any mistakes in this, because those will be annoying later. Like if I get a working solution but I get a wrong answer, I definitely should come back and double check that all this is right. But let's double check it again now real quick. So we have 0, we have 1, we have 2, we have 3 with 2 E's, we have 4, we have 5, we have 6, that looks right, we have 7 with 2 E's, we have E, I, G, H, T, and we have 9. Okay, so that looks right, and the code should still run. Okay, all right, so Oh, you're right. Thank you. Thank you. Thank you. Morgan the Third, thanks for coming in the stream, and thank you for pointing out that important mistake. Okay, so 9 has 2 ends. Oh, no. I was not talking to you, Mr. Google Assistant. Okay, so we have the frequency of all the digits, and we have the frequencies of the input string. So I'm going to implement this as a backtracking solution. So let's create a function backtrack and try to conceptualize what needs to happen here. So how do I want to do this? Oh, okay. So basically what we're trying to do is we're trying to get all the frequencies of the characters in the input string. We're trying to get them all to be 0 and nothing left to do, right? So for example, as I'm going through my solution, I'm going to be matching up elements of this digits array with elements in the input string. So for example, let's say that as I'm writing my solution, at some point I'm going to try to put the string for the number 1 into it. So what I'll do is I'll go into this frequency table, and I'll subtract 1 from the O's, I'll subtract 1 from the N's, and I'll subtract 1 from the E's, assuming that there is at least 1 of each, right? If I have like 0 N's in there in this frequency table, then I would not be able to attempt to put a 1 in there, or any other digit that uses an N. So, but let's assume that I can do a 1. So I'll subtract all of these frequencies here. I'll subtract from this frequency table. And then I'll just keep going. If I get to the point where I can't match, any more digits, but I still have some frequencies left here, then I need to that's when I need to start backtracking. However, if I get to the point while I'm backtracking where every single frequency in this table is 0, then I'm done. RSGGs, can there be the same number twice? I think so. Did they say that there couldn't? So, okay. So they basically say that there can be because of what the length of the input string is, right? The input string can have up to 10 to the 5th characters in it. So even if you took the digits 1 to 9 and you just jumbled those up, you'd have like less than 100 characters. Yeah. Hopefully backtracking is fast enough to get accepted for this. I'm not sure if there's a better solution. So for the backtrack function, also I need to go pee again. I've been drinking a lot of water today. But I'll try to get a little bit more code written, and then I'll take a quick bathroom break. We pass in the frequencies. And the other thing that we want to do is we want to keep track of once. I think this will make the solution easier to write. If we keep track of how many frequencies in the frequency array have hit 0. So int num, let's call it num non-zero frequencies. Number of non-zero frequencies, and at the very beginning of the program, this is going to be equal to frequency.size. So S is guaranteed to be valid, which is why the only possible characters are this subset of the alphabet. So we have our number of non-zero frequencies, and we're going to backtrack. So we already know that we're going to backtrack, and we're going to backtrack and we're going to pass in the frequency table, and we're going to pass in our number of non-zero frequencies. And then, so this is a recursive function call, and that's the reason I'm using this. I think it'll just make it a little bit easier to write. So as soon as, if this function gets called and a number of non-zero frequencies equals, hold on, I just got confused, but I had this figured out a moment ago. So the number of non-zero frequencies starts off as the number of basically unique letters in the input. We want to get the number of non-zero frequencies down to 0. Is that what it is? Yeah. Okay, it is. It's just, I was thinking about it backwards for a second. So once we get the number of non-zero frequencies down to 0, then we're good. Oh, and then the other thing that's pretty important is this like string that ends up getting returned as the answer to the problem. We need to be like building that along the way. So as we're like trying to put like a 1 or a 5 in, we actually, let's say that we do like put a 1 in, we add the digit 1 to our answer. And then the only other little twist here is that they want you to return the digits in ascending order, even though the digits in the input are not, or because they're just completely jumbled mess. So the last thing that we do before we return the answer is we just sort it, right? So string answer starts off as empty string, and then we'll pass in the answer as well here. We'll pass in the answer. So that's going to be, we need to be a string reference answer, and then int number of non-zero frequencies, which that's the number we're trying to get down to 0. So every time we like, let's say that we take this 6 and we apply it, so we'd subtract an S, an I, and an X from the frequency here. If S or I or X or more than one of those goes down to 0 in the frequency table, we adjust this number for the next backtrack call. So here we return the answer, and all I'm going to do here is leave myself a to-do comment saying sort the answer before returning. Oh, there might even be an easier way to do it than that. We could use a multi-set too. Maybe, do I just whip out the old multi-set for this? It's not often that you can use a multi-set. That sounds like fun. Unordered multi-set of char answer set. Let's use that. So multi-set is like a normal set, if you don't know, except that you're allowed to have duplicates. So let's create that here, and we'll pass that in like that, which means that the multi-set gets passed in here. And honestly, because there's a very limited number of chars that could possibly go in there, it might even be more efficient to just do a standard multi-set here. If I do a standard multi-set, then the contents is going to be completely sorted. So it'll be easy to iterate over it and get my answer out. And insertions and deletions can be thought of as constant time because you know that you're only going to have the digits 0 to 9 in there. So there's only 10 possibilities. So I'm going to try to do it this way. So let's continue to return empty string. And then this to-do comment just becomes build the answer from the answer set. Okay, so now that all of that's in place, I think we're actually well on the way to having a solution. So I'm gonna, I warned you guys a moment ago. I promise I won't be gone long, like probably less than 2 minutes, but I need to have a quick bathroom break. So be right back. Okay, let's get this one solved. Okay, so backtrack, we got a frequency, our answer set. While I was using the restroom, I was already having second thoughts about the multi-set. I don't think it's necessary, but there's a bunch of different ways you can do it. Honestly, like as you're going through the backtracking process and you're building your answer, there's a bunch of different ways you could store it, and I don't think that there's a huge difference, like performance-wise, between all the options you have. Because you could create another frequency table for the answer, which is the digits 0 to 9 and the number of times they appear in the answer. You could also just have a string where you append stuff on the end, and then as you backtrack, you're just popping off again. It would be like a... I don't really want to call it a stack. You could think of it as a stack though, because the call, you know, all the calls to backtrack form a call stack. So let's stick with the multi-set, and then if I want to change it later, I always can. So let's just get in here. So okay, I think having this function return a bool is going to be valuable. So basically, when backtrack starts returning true, that's indicating that it's finished because it found a solution. So the way that we know that happens is if we hit number of non-zero frequencies of 0. Yeah, that's right. So that's where we return true. Okay, now the next step is to iterate through the digits 0 through 9 and try them all. Alexa, shut up. I don't know why she perked up right there, but it's really annoying when I'm trying to think. So for int I equals 0, I don't like I for this. We'll call it x. For int x equals 0, x is less than 10, plus plus x. So this is the simple part of the backtrack, is that we're literally just going to try all the different possibilities. So X represents the digit that we're trying to put in the answer. That's what it represents. So unordered map from char to int. Here, let's call this all digits up here, and then we can just call this one digits, and we're gonna get the xth element out. So sorry, digits equals all digits x. So we're just getting out the digits for the specific digit. Digits is not a good name for this, is it? The indices are the digits, but what's in there is the digit frequencies. Let's call it all digit frequencies, freaks, all digit freaks, and then we'll call this digit freaks. So basically the frequency table for the letters for a specific digit. Okay, I think that makes sense. Now what we want to do is we want to go through all of the digits here in digit freaks, all the letters, and most importantly, we need to make sure that it's going to work, right? So we're going to compare to make sure that there's at least all the digit freaks here also are in the main frequency table here. So for, and it's probably going to be easier to just make an iterator. So for an iterator equals digit freak dot begin. The iterator is not equal to digit frequency dot end plus iterator. This is one way that you can iterate through the entries in a unordered map. So you got your iterator, and so what you have is your char. You have your char C is going to be the first thing in there, and you have your int count is going to be the second thing. And so basically we're iterating through this unordered map, and we're going to be able to pull out that for the number 6, that S is 1, I is 1, and X is 1. So let's try to see, so what we're trying to do right now is we're trying to prove that this fits. So bool fits. Let's just start it off at true and try to prove that it doesn't fit. And the way we know it doesn't fit is if the frequency of C, so if the frequency of C is less than the count, then it doesn't fit. Fits equals false, and then we can also break out of this loop because there's nothing left to do. Now if it's equal to or greater than the count, then we're good. So if we get down here, and it doesn't fit, we continue on to the next digit. That seems pretty straightforward. Now, if we get to line 33 of the code, it does fit, so we have to then use it. So this is where the backtracking comes in. Let's do that again. Well, not all of that, but some of that. So now we get our, we already know it fits, so now we're going to update our frequency of C minus equals count. So the backtracking part is going to be here. Not sure. I'm assuming that most people in. Well, I don't even know how many people are watching. I don't have a viewer count. Could be that nobody's watching, but if there were people watching, I would assume that some people are more familiar with backtracking than others. But the backtracking part is where you actually like apply a change, and then you continue onwards to see if that change works. So you update the frequency and you subtract the count. Then the other thing you want to do is you want to add the digit to the set. Oh, and it just occurred to me, this should be a multi-set of int, not a multi-set of char. Let me update that here, here, and here. Answer set dot insert x. Oh wait. This happens. This happens down here. So all of this is the backtracking part. This comment should be down here. So we insert x into the answer set. We decrease all the frequencies. We also want to make sure we're keeping track of the number of non-zero frequencies. So if I subtract the count here and frequency of C hits 0, if frequency of C, if that hits 0, then we have one fewer non-zero frequencies, so we subtract from that. Let me know if anyone has any questions about this. I'm fairly comfortable with backtracking, at least like some backtracking. Like this problem, for example, this makes a lot of sense to me, so I can try to go into detail if anyone wants to know. So we're backtracking, so we insert x into the answer set. Then we go through those frequencies of the digit again, and we update them all in the frequency table. And then if we hit a 0 frequency, we reflect that here. And then here's the next thing we do. We backtrack. So backtrack. Oh yeah. So remember how backtrack returns a Boolean. So if we backtrack from here and we get true, we keep returning true down the line, and that's what ultimately terminates this process, is because we keep returning true all the way down the line. So if we backtrack and we're passing in frequency, answer set, and the number of non-zero flags, the number of non-zero frequencies. Yeah. Sorry, I just had to think about that. So honestly, this variable name keeps confusing me, and that's probably my fault for not naming it well. So we backtrack, and if we backtrack and it returns true, then we return true, and then whoop, it'll go all the way back to the beginning. Everyone's returning true, return true, return true, return true, and this then and that starts when this happens. Right, it starts when we've used up everything in the input. We've consumed all of the characters, and we've made a complete set of digits out of it. And so we start returning true here, then we keep returning true all the way through, and then ultimately the program will get back to here, and we'll have to build our answer from the answer set. However, the news isn't always this good. Sometimes backtrack will return false, and so we also need to add the case for returning false, which is down here. So basically, the idea is, as we're going through the backtrack, we're trying all 10 digits. If we try all 10, if we get through this for loop, we've tried all 10, and we have not started returning true, we have not found an answer at all, then we return false. because it didn't work. So if we get here, this is where the backtracking comes in. If we call backtrack and it doesn't return true and the program gets here to line 48, we now need to undo everything we just did. So we need to answer set dot remove x. This is actually not right, but we need to undo everything, right? So we remove x, and we then we go through these digits again, and we want to add them back in. We're basically just undoing what we just did, so we can try something else. So first of all, if the frequency was 0, we re-increase the number of non-zero frequencies, and then we add the count, like that. And I think that's good. Now we need to fix this, because in a multi-set, when you call remove like this, or it's actually erase, it'll erase them all. So we just want to erase one. So the way to erase just one is actually to get an iterator to the first one that it can find. So answer set dot find, and we need to store it too. So we need to store this iterator. Hold on, I did see a chat message come through. I'll read that in a sec. Auto it equals answer dot find x, and then we can just erase it through plus it, and then that should just delete one of them. I probably have some syntax errors, so let's just run the code and see what happens. Okay, I don't have syntax errors. The program compiles and runs, but that doesn't mean it's right, so I'll check that in a sec. Morgan the Third. Oh, sorry. That Onion, thank you for the follow. Really appreciate it. Follower goal is 4 out of 5, which is actually pretty pog. Morgan Third, I have no idea how time consuming it is, but if you remove the digits in the correct order, you can subtract the letters from them one at a time from a big pool, and you have to only count the number of unique letters for each number. For example, oh, that's smart. Yeah, I think that's smart. Yeah. I think that's probably a lot more efficient than what I'm doing. Yeah, so x, like you said there in your message, x only exists in 6. So if we have like 10 x's, we know that we're using also 10 s's and 10 i's. 19-028-W. Not sure how to read that. Yeah, G for 8. So you do those first, and then, I wonder if my solution is fast enough to get accepted, or if I'm supposed to be doing it that way, the way that you said, because the way that you said does make sense. The way that you said does make sense. But I think I am close to actually being able to produce an answer from the code that I've written here. Morgan the Third. Oh yeah, it won't work in every language. True. So I guess you could consider backtracking like a more universal approach, but in languages like English, where some of the numbers have letters that are very unique to them, you could do it. RS, GS, GGs. Yeah, I'm getting there. That is really interesting though, Morgan the Third. Thanks for pointing that out as another approach. I bet that they talk about that in the solution tab. Okay, so we find an iterator for the answer, we erase it, an iterator for the x. If the frequency was 0, we re-increment number of non-zero frequencies. If the frequency, okay, and then we add the count back onto it, and then we will return false if none of those worked. Okay, next, so that might all be right, or there might be a bug there, but the next step is to check out what we got in answer set. And then build it into a string. Before I build it into a string, I just want to see what's in it. So before I build it into a string, I just want to look inside. So let's get an iterator to the beginning. And if what's inside is right, then I'll write some code to turn this into a string. Answer set.begin, it is not equal to answer set.end. Plus plus it, and cout star it space, and then cout new line. Morgan the Third, thanks for following. Thanks for helping me hit my my follower goal for today. I really appreciate it. Okay, check that out. So that did work. So at least something's working, because we did get the right answer for one of the test cases. Let's use another test case. Let's use the 5-4, and let's see if we get 5-4. What is this? Is this a Stack Overflow? Oh, no, okay, it worked. It worked. So the good news is we got 0, 1, 2 for the first case. We got 4, 5 for the second case. We need to build it into a string. I'll do that in a second. Because I'm using a normal multiset, which does store things in order, I can just iterate through it one element at a time and append to a string. If I was using an unordered set, then I would have to order it myself, which would mean iterating through the digits 0 to 9 and just grabbing them out. But this will work. So let's create our answer string, which starts off with empty string, and we'll append to it answer plus equals star it. Is that it? Is that all we need to do there? I probably could have just done that originally instead of logging it out, but you know, my brain told me to log it out first, so that's what I did. What's going on here? Oh, I need to convert these to chars. I know how to do that. So for these, I just need to add the ASCII value for 0. Is that right? Is that the smart way to do that? Yeah, it is. It is. Yeah, because these what I was storing in the answer multiset was the actual integer for the digit. But in order to make that into a string, I have to then convert those into the ASCII digits. And so the way you can do that is you can just take the ASCII value for the 0 and add it to everything. And that fixes that. So now the big question is, does this get accepted when I hit the actual submit button? I hope it does. Let's see. Submit. The time complexity of my logic.
I don't know what y'all think, but I think that's pretty.
It's definitely worse than linear. So what's the worst case scenario? I don't even know. I don't even know how to analyze the time complexity of this, which is probably a bad sign. So basically, I try like 4 to 5, I try 3 to 5 letters at a time, right? Because 1 through 8, oh no, 3 to 6 letters at a time. And there's 10 possibilities, so like let's just say 60. Each call to the backtrack function checks up to 60 things, but because it's exactly 60 though, you could consider it constant. Like it never gets any more than that. Like, so I think every single call to the backtrack function can be thought of as constant, because every single call here does a constant amount of work. We always try exactly 10 digits. The maximum number of characters in each digit is 6, which is for 8. So then, since we know that, it becomes what is the number of calls? What's the worst case for the number of calls to backtracking, to the backtrack function? And the worst case would be, so it only moves forward with the backtrack if one of the digits fits. I don't know. There's probably backtracking complexity. There's probably like a known way to analyze complexity of a backtracking algorithm. Let's see what people say here. 2 to the n. Hamiltonian cycle is n factorial. Maybe is it factorial? Is my complexity might be factorial. So we could divide the maximum number of the input string, which is 100,000. We divide that by 6. No, we divide it by 3, and that's the most possible digits that could be in there if they're all like ones, 2s. You know, I don't know how to analyze it. It's weird. Let's submit. It's too slow. It's too slow, which means I do have to do what you were saying. And this is the test case that I failed on. So I think what I can do is, so the question is, does what you suggested, Morgan, can I use that approach to get to the final answer? Or can I use it to significantly optimize my solution, but I still have to backtrack eventually? And I think in order to figure that out, you actually have to so yeah. So you have a number of letters, then for every x in there, you subtract 6. Then you go to something like G, and you take care of all the EIs, Gs, Hs, and Ts in 8. Then you take something like W for 2. If you get rid of all the 4s, there are no Fs left for 5, or right, or wrong Fs. So if you, yeah. So basically you set it up so that you're constantly narrowing down what the remaining possibilities are. So like if you do 6, then the next thing you can check is 8. Then the next thing you could check is 2. I wonder if I could incorporate that into my solution by changing the order that I look at the digits here. Like what if I were to look at the 6s first here? You know what I mean? Because then I would subtract out all of the X's and I's and S's. Yeah. So this is a really interesting problem. I think I might be at the point where I check out what they recommend for this one. Because I'm actually, even though I didn't get accepted, I am happy that I wrote a solution that works. And it's always good practice to write a backtracking solution, even though in this case the backtracking solution is too slow. I'm pretty sure it is at least correct though. So let's have a peek here. So the naive approach would be to construct as many zeros as it's possible from the letters in the input, then as many ones as possible. The problem is that letters O, N, E could be present as well as the other in another number, so it could be misleading. So the idea is to look for something unique. Right. So this is what you were talking about. So the Z is unique to 0, the W is unique to 2, the U is unique to 4, the X is unique to 6, and the G is unique to 8. Hence, there is a good way to count even numbers. Oh, okay. Okay, so that seems coincidental, but the digits with unique letters are 0, 2, 4, 6, and 8. So, okay, let's keep going. That is actually the key how to count 3s, 5s, and 7s, since some of the letters are present only in one odd and one even number. So H is present only in 3 and 8, F is present only in 5 and 4, S is present only in 7 and 6. So you do those next. Now one needs to count 9s and 1s only, and the logic is basically the same. I is present in 9, 5, 6, and 8. So let's see. Let's look at the code. Okay, so here they are creating a frequency table. I have that too. That's my FREQ thing. Building out hash map. Building out the hash map digit to its frequency. Oh, I see, okay. And then how do they generate an answer? So they create a string builder. They iterate through the 10 digits. Then they iterate j equals 0. J is less than out I. Oh, that's yeah, I see. So once they do exactly what they said they were going to do for 0, 2, 4, 6, and 8. Then for 3, it's the number of H's minus the number of 8's that you did. Right? Yeah, it is. So the total number of 3's in the answer is the total number of H's minus the number of 8's that you found, because the 8's have the unique letter of G. Then the number of 5's in the answer is the total number of F's minus the number of 4's. Yeah. So then, wow, that's cool. And the time complexity is linear, and the space complexity is 1. Comment 1 is someone saying that they were thinking of backtracking all this time. Me too. Me too. Until Morgan, you pointed out the optimizations. I too was thinking of backtracking all this time. The problem statement needs to be reworded so it's more clear. I had to read the... okay. This is one of the worst questions to ask in an interview, and unfortunately, Expedia asks this. With the right hints, the problem looks not bad. How about pay attention to your unique letters and numbers? Yeah, that's a good point. Because once you understand the relationships between the numbers, it's really easy to solve. Okay. Who was it that suggested that? I thought it was someone that left the chat. Oh, RSGGs, you suggested that problem. And then you said it's a pretty bad question, but curious what my initial thought process would be. So out of curiosity, were you able to get it? What was your, what happened? What happened when you attempted this? Time reveal. Welcome. Welcome, welcome, welcome. Gave up after an hour? Yeah. Yeah. Well, I'm satisfied that I got a working backtrack algorithm, even though it's much too slow to actually get accepted. Yeah, okay, you gave up after an hour and viewed the solution. Yeah. I don't think I'm going to implement the solution now that I know it, though. I'm going to leave this problem unsolved. And then at some point in the future... I will probably end up coming back to it after not having read the solution for a while, and then hopefully I'll remember. That's what I'm gonna do. Yeah, the pattern. Yup. Okay, so I think I've been live on LeetCode for 3 hours and 34 minutes. I'm gonna do 1 or 2 last problems. And they're going to be from the dynamic programming study plan. Right here. I've been doing the study plan, so I completed days 1 through 3. And next I'm going to look at the jump game, and maybe a jump game too after that, but at least the jump game. RSGGs, thank you for stopping by. Thank you for following. I appreciate you being active in the chat, and I'm glad you were entertained. Yeah, I'll be doing more of this, so I do hope to see you back. Have a good night. Thanks for just suggesting a problem too. That was an interesting one. Looking at the jump game. Also, time reveal. I think I already said this, but welcome. Thanks for coming in and starting us off with a lull. Hope you're having a good evening. Are you into... I mean, feel free to just lurk, but if you want to chat, are you into LeetCode? Are you... What's your sitch? What is your sitch? So, you were given an integer array nums. You are initially positioned at the array's first index, and each element in the array represents the maximum jump length at that position. Yeah. Return true if you can reach the last index, or false otherwise. So, in the case of 23114, the output is true because you can jump 1 step to the 3 and then 3 steps to the end. In example 2, you get 32104, and it's false because you will always arrive at index 3 no matter what. So, oh, okay. So each element represents your maximum jump length. So if you get a 3, you could jump to any of these 2 and end up on, but you still end up on a 0 where you cannot proceed from. Time reveal, easy question? I'm glad you think so. I'm glad you think so. I don't know if it's going to be easy for me. I've got an idea though. Yeah, the staircase problem. I solved the staircase problem a couple of days ago because it was part of the. It is part of the study plan that I'm doing. So yeah. So there's like climbing stairs and min cost climbing stairs, and I got those. So you want to know if you can get to the last one. So if you want to know that you can get to the last one, then there needs to be a 1 here, a 2 here, a 3 here, or a 4 here, right? I think that's probably how you approach this. So you want to get to... Okay, yeah, you want to get to index 4, which also happens to be a 4. So in order to get here, there has to be a 1 here, or a 2 here, or a 3 here, or a 4 here. And then if there is, like, let's say that there had been a 1 here, then you do the same thing. There has to be a 1 here, a 2 here, or a 3 here. And in the case of this input, there is all 3 of those. So how do you approach this as a DP? So do you iterate backwards? Do you iterate backwards through the array? You need to see a 1 here. If you don't find a 1 here, you just can ignore it. If you don't find a 2 here, you can just ignore it. But then, like, if you do find a 1 here, then now you have the same problem, but repeated further up. Like then it's like, assuming that you have a 1 here, the question is, okay, now I know I can get from here to here, but can I get from the beginning to here? So I'm trying to figure out how you represent this as a DP, because that's obviously going to be part of the answer. So n is num size, and then we're probably going to have like a vector of int dp, probably of size n. And then usually my approach to these is I try to figure out what dp of I means. So let's say that we're iterating backwards, because I think that's probably part of the solution to this. So I equals n minus 1, I is greater than or equal to 0, minus minus I. And so dp of I would be, dp of I, is it a bool? Is it just like whether or not you can get here? I'm vibing with this song. So let's think about it. Okay, so I'm looking at the 4, which means I need a 1 here. Actually, I don't need a 1 here. I need anything greater than a 1 here, right? Like if I had a 20 here, that would be fine. I just have to have something greater than 0 here. I have to have something greater than 1 here. So like this position needs to be greater than 0, which it's not. This position needs to be greater than 1, which it's not. Yeah, like, just because of this specific test case and how they structured it, it's set up so that none of these are going to work. This needs to be greater than 1, this needs to be greater than 0. Three, two, 1, 0, 4. We're trying to get to the end. And if this had been greater than 1, So, is this n squared? How many numbers do you get? You get 1,000. You get 10,000 numbers. Because I've been trying to think about this in terms of linear, but this might not be linear, right? Like, if I'm starting at the end here, and I look at all these, like this needs to be greater than 0. Yeah, like I can look at all that, and so I can basically figure out if there's a way to get from any of these to the 4. And then I keep going back. And I look at the 0. And now the question is, is n squared too slow though? Is there a way to do this in linear time? No, there isn't, right? This is the first, because so in the study plan, all the ones I've solved so far, so Fibonacci, stairs, house robber, all these were linear time DPs. And it's possible that now on the jump game, this is the first n squared time one. N squared time, but linear space, maybe. So let's just think about this here. So int j equals I minus 1. J is greater than, and this now I is greater than or equal to 1. And j is greater than or equal to 0. Minus 1 is j. And so now we're looking at like these two. And what do we want to store in the DP array? Is it bools? We just store bools of whether or not you can reach the end from this position. Forwards and not backwards. So if we were going forwards, we'd be at the 3. And so we could go forwards here, here, and here. And we know that we could reach all of those. So do we like flag them in like a bool array as like still reachable? And then as we're going forward, we just skip things that are not reachable? Track of the furthest index. Okay, let me try to do it the way you're suggesting. So let me try this. Vector bool. Thanks for hanging out, by the way, and offering insight on the problems. Like, I definitely don't want spoilers. Like, if someone came in here and just outright was like pasting code, I wouldn't be a big fan. But brainstorming together, like if I'm struggling, is perfectly acceptable. So reachable, false. Yeah, start them all. Start them all off at false. Reachable 0 is true. And then after the program is done running, we just return reachable n-1. Yeah, I think you might be right about that. And so now we start off at I equals 1. No. Yeah, we start at I equals 0. I is less than n plus I. Actually, we don't need to look at n. We can stop at n-1. Literally doesn't matter what the last index of the input is. So then we for int j. Oh yeah, so if the current spot's not reachable, we continue. If we're not reachable here, we continue. Everything starts off as not reachable, except for the first spot, which is reachable. Then whatever number is there, we can mark things as reachable up to that distance away. For int j equals 0, 1. Might as well start off at least 1. J is less than or equal to nums sub I plus j. We can add another condition in here. J is less than or equal to num sub I, and j is less than n. No. J is less than I plus j is less than n. Is that right? Yeah, that looks right. Reachable I plus j is true. Is that it? Run code. Okay, so use the example test cases. Thank you, Morgan, for pointing out that I was thinking about it maybe slightly more complicatedly than I need to. Okay, let's submit. The question is, so hold on, before I submit, what's the worst case runtime of this, right? So num sub I is guaranteed to be less than 10 to the 5th, and the length of the array is guaranteed to be less than or equal to 10 to the 4th. So worst case scenario is that they give you a full array of numbers and all of them are really high, like 10 to the 5th. And in that case, you would end up with something like O of n times k, n times m, where n is nums.size and m is well, basically m is 100,000, but you could think of it as m is about the max of nums, max element of nums. So I'm actually not 100% sure if this is right. There might be a faster way to do this, but I'm going to submit. Okay, there is a faster way to do it. Too slow. Morgan, you said, I bet you could do something clever like count back from the furthest you can leap. Skip forward as soon as you can. I've been coding for a while, not gonna lie. 4 straight hours of LeetCode, but I should definitely be able to get this one. Like, this is not supposed to be a particularly difficult DP. And something like this would definitely be reasonable for an interview. Oh, you're good, you're good. No, I appreciate you being active in the chat and brainstorming with me. Do something clever like count back from the furthest you can leap. That might speed it up a little bit. Skip forward as soon as you can. See, what I'm thinking though, what I'm thinking is that they want this to be O of n or O of m or O of n plus m or O of n log m, something like that's what I'm that's the terms. Then like that's where my brain is going right now, because clearly n times n is too slow for this, so you have to remove a significant amount of work in order to get this. So there's probably a way to represent the DP in such a way that you can do it quicker. So I think I'm trying to think about it from the end again. So if I'm at the end, there needs to be here. If you have really big numbers, you skip forward faster. So if I get to a spot and it's not reachable, I continue. Otherwise, so I understand what I think I understand what you're saying. What I'm wondering is, what if the input is structured in such a way that your solution runs in like a worst case way? Is the worst case still better than n times m? You haven't taken any classes on algorithms or optimization. That's all good. There's no degree requirement to be in the chat. I'm just happy that you're here, honestly. Can you imagine like a Twitch chat where you have to have a CS degree to be in it? That'd be some fucked up shit. You don't know how a computer handles n. The idea behind n is like, if n is the number of numbers in the input, then if I say that an algorithm is O of n, that means I'm doing at least that many, I'm doing like that many operations. Like but it could be like more though, like it could be like 5 times n. Like let's say you have a for loop over all the numbers and you like do 5 things. Your O would be 5 times n, but then that just becomes O of n. It's treated as the same thing. So O of n times n means that in the worst case, my code is going to run in like 10 to the 4th times 10 to the 5th operations or so, which is too many. I think I'm just missing a crucial observation here that turns this into a linear algorithm. Because it's definitely not quadratic. So I remember my buddy talking about it. I just don't know when having big numbers matters and when it doesn't when handling programming objects. Gotcha. So if I start from the end, Let's say that I'm starting from the end and I'm marking whether or not it's possible to get to the end from the current position. So I start at the end. So this is kind of what I was thinking about earlier. Let's go back to thinking about this problem in reverse for a second. 2, 3, 1, 1, 4. So you're at the end, and so you know that you need at least 1 here, at least 2 here, at least 3 here, at least 4 here. So maybe I kind of do it that way, and I start at the end and I iterate all the way back to the beginning of the array. And if there's not enough number in each spot to jump to the end, then I set it to false. Why does this feel so hard? It's probably because I've been coding for too long. So we're gonna have a parallel array of booleans, and we start them all off at 1, indicating that it's possible to reach the end from this position. And then we go here. Now this is a 1, so it's still possible to reach the end from that position. Now I go here. This is a 1. It's still possible to reach the end from that position because there's a 1 here. A 3. Wait a minute, what if... Seas of zeros help somehow? Like look for zeros and see if we can bridge each gap. Ooh. I don't mind the thought process there. Okay, oh, time reveal. You think starting from the end is right? I think so too, but I do like the idea behind the zeros, because anytime that you're, like for example, if there's no zeros at all, the answer is just true. As soon as you find a 0, you just need to be able to bridge it. Or if you find a string of zeros. So what if dp of I equals that you can get to the end from I. Start everything off as true. And then, so that means dp of I equals dp of I minus 1 I feel like I think the problem needs to be represented this way. Like I should be able to figure out whether or not I can get to the current position based on whether or not I was able to get to the previous position. But then do I still need to loop there though? dp of I minus 1, it's true if dp of I minus 1 and dp of I minus 1 is greater than or equal to 1, right? Or so this is where the loop comes in. Do we need to have a second loop? But maybe the second loop just runs faster if you do it this way. Or dp of I minus 2 and dp of I minus 2 is greater than or equal to 2. Then as we're going backwards though, we just get to skip over stuff that we already know is reachable. Maybe my code's not far off. Hold on a sec. So I go from 0. If 0 is not reachable, I continue. Is the problem that I'm doing this wrong? Should I be starting off looking as far ahead as possible? Does this change anything? No, it changes the fact that the program is no longer correct. Gigantic bucket, yes, I have interviews coming up. I've been doing LeetCode live every day for what, 6 days now? Yes, 6 days now. Today I'm 4 hours and 15 minutes in, and honestly I'm a little frustrated that I'm struggling so much with this DP problem. Time reveal. Feel free to throw out some more hints if you think you know something that'll work, because I'm definitely having some trouble. But yeah, gigantic bucket, the answer is yes. I am interviewing soon, so I gotta like review and practice a bunch of this stuff. So how did I break the program? Oh, wait. Staircase problem. So, when you say staircase problem, are you talking about being able to jump 1 or 2 steps? Because the big difference here is it's not 1 or 2 steps, right? It's like you can jump up to like 3, like whatever number's in the array. You can jump that many. But I still think you're right in that the solution is similar to, okay, I'm going to delete all this. I need to spend some time thinking a little bit more about this, because there's got to be, obviously quadratic solution doesn't work, so there's got to be a way to cut out a bunch of the work that we're doing. But so the DP solution that you're thinking of, what would be the time complexity of it? Because the code that I just wrote that that I submitted earlier, that TLE'd, I'm pretty sure that was very similar to staircase, but it TLE'd. So starting from the end, and then you go back here, you can move one ahead, so you're still good. You go back here, you can move one ahead, so you're still good. So at every point, starting from the end, at every point, you just want to know whether you can still get to the end from this point, right? So you have a 1, so this is, so you have true, true, true. But so here you have a 3 though. So for the 3, it's true if any of these 3 are true. Right? So you still have to have an inner for loop that counts this many times. But it can break early though. Like if this is true, it can stop immediately. If this is true, it can stop immediately. Oh, wait. No. We don't actually want to get here if this is false, right? Memoization. Vector bool dp n false. Is it bool or do we need ints? dp of n minus 1 equals true. Right. For int I equals n minus 2. I is greater than or equal to 0. Minus I. So the way that we're structuring the problem is that we just want to be able to return dp of 0. So what if we, what if we had zeros in here? What if there was a 0 there, okay? So 4 is true, 1 is true, 1 is true, because each time we can, if you start from the second to last, can you get to the last? Right. Now when we get to the 0, false? It's false for 0? Because, yeah, so, oh, that's an interesting observation. If you're at any 0, you automatically can't get to the end. Okay, let's see here. So dp of I equals dp of I plus 1, but only if dp of I is not a 0. Here's what I think. So we do have a number of a number that we can jump at. We have like, I don't know, k. It's going to end up being j. It's going to end up being j anyway. So j is num sub I. That's how far we can jump. And let's do this. If not J, that's like, okay, so J is like the max we need to look forward to flip something from false to true. But as soon as we find something that's already true, we can stop, right? So for int I equals 0, so int J is nums I. J is we started off at 0. I think it could start off at either one. Nums I, J is greater than 0 minus minus J. So if dp of I plus j, okay, so we do need I plus j to be less than n. So if dp of ij, then dp of I equals true, break. Is that it? Is that gonna work? That's a crash. I messed something up. Thoughts? Yeah, gigantic bucket. Like, if you're super experienced and you can look at this and you just immediately know the answer, the only thing I ask is that you don't just like paste it in. But if you want to guide me in the right direction, yeah, that's completely fine. So, trying to get any solve. I do want to use DP for practice though. Yeah, I definitely want to use DP for practice. I feel good about what I'm trying to do here, but now I just got to figure out why the program's crashing. So I start I off at n-2, I iterate all the way through to the front, then I start j off at nums sub I, and I keep going while it's greater than 0. I plus j is less than n. Oh, yeah, that's right. So basically, if j is 0, then this loop just doesn't run at all. Where's the out of bounds exception? Oh. Yeah, sure. Yeah, you can draw it out. You have a non-DP solve. Interesting. Yeah, I encountered this problem under the DP study plan, because that's what I'm trying to practice. So you see here on day 4, there's Jump Game and Jump Game 2. So that's why I'm here. If I go to related topics, it does mention dynamic programming. Oh, interesting. So it mentions greedy. Oh, whoa, look at all the jump games there are. Jump game 2, 3, 7, 8. That's a lot of jump games. So it does say greedy, so... Oh, DP becomes more required for part 2. I see. So for jump game 2, what do they change? Given an array of non-negative integers, nums, you are initially positioned at the start. Each element represents your maximum jump length. Your goal is to reach the last index in the minimum. Okay, yeah. So now I feel really dumb. Because for jump game 2, you have to minimize. Whereas jump game 1, you just have to say whether or not you can get there. Yeah, it feels forced for this one. Okay. I'm kind of annoyed. So, Time Reveal said he was drawing something up for me, which I will take a look at. So if there's a 2 here, I know that... So for this one, okay. Since we know we're gonna need DP for the next one, maybe I should think about this differently. For int I equals 0, maybe because I was trying to force it into the DP mold, that's what was confusing me. Let's try to think about this non-DP. Plus I. So what if we're keeping track of the farthest we can possibly go? The farthest we can reach. So if we're at the first index and we have a 2. So we know we can get all the way to the second index. We know we can get all the way to index 2. I don't know, Gigantic Bucket, what do you think, do you have a hint? Do you have a hint that you can throw me that doesn't just scream out a very specific line of code? I don't know how to ask for hints. Like, I don't want you to like blatantly give it away, but do you have a guiding question? Do you have a guiding thought? I would take a guiding question or a guiding thought, because I feel like this is supposed to be really obvious, but I've also been working on this for a while. Each element represents your maximum jump length. Oh wait, can you solve this with 2 pointers? Can you solve this with 2 pointers? Is there a pointer I for where you're at and then a pointer J for the farthest you've gone? And you just keep increasing J? Can you change the I value in the for loop conditionally? Yeah, I mean, you can do that. I'm not sure I understand what you mean, Morgan, but like, I can change I in here if I want, and I could wrap that in an if. Like, this is something that you would be allowed to do. Okay, so Gigantic Bucket says that seems smart. Okay, so I'm gonna try that. So 2 pointers. So int I equals 0. We'll have int j also be here. J also starts, so I is just where we're currently looking. J is going to be the farthest we know that we can reach, which is 0. So let's get the jump size for the current position. So let's just call it x equals num sub I. And then if, so j equals the max. Wait, I need j out here, right? Int j equals 0. And what we want to do is we want to return j is greater than or equal to n minus 1. J is going to be the max of j, and I plus x. Okay, this is a linear algorithm, and if this is right, this should definitely work. Oh, don't need int here. Okay, so it doesn't quite work yet. I'm missing something important. Yeah. Thanks, man. So Gigantic Bucket, what's your background in this? Like, send me your LeetCode profile. Are you like really experienced? Okay, I'm missing something, which is that if I get to an index and it's less than j, if I is less than j, we break, right? Is that what I'm missing? No, fuck. Is it the other way around? If j is less than I? Because we get to a point where we're at a tile that we can't reach. So I could actually include that condition here. I is less than n, and I is less than Caparino GR. An inefficient way could be I is less than some I plus 1 length. I'm not sure I follow what you mean. What do you mean by brackets I at the beginning there? Sum of I plus 1 to I length. So I've already been through several iterations of solutions to this, and I came up with one that I'm pretty sure was right, but it TLE'd. Gigantic Bucket, so you say you've done a good bit of competitive programming, competitor, coach, judge, problem writing, and interviewing candidates. Okay, so you're very experienced at this. Don't have a good one-stop LeetCode kind of thing. So when you say judging, what's the extent of that? Like in what situations have you judged for this? Also, it's cool that you've also done problem writing. So J starts at 0, J representing the farthest we can possibly jump. No, J representing the farthest position we know that we can jump to. So it starts off at 0. And then we come in here, I is 0, J is 0. Oh wait, this is not going to work on the first iteration. J is nums 0. Is that what I was missing? Okay, so then we come into the loop, I is 0. Oh, okay, I don't need to reset j to 0 there. Okay. All right, so for the first time in a bit, the good news is I'm passing the predefined test cases. Submit. Fuck. Doesn't work for 1, 2, 3. Why doesn't it work for 1, 2, 3? Well, let's figure that out. Familiar with ACM? Yeah, I am. I went to college and we competed in some of those. The problem writers who also construct data sets, etc., call themselves judges. A bit of a weird term since most judging is automated. Okay, cool. Yeah, yeah, I've competed in some ACM contests. It's been a long time though. Like that was back in 2016. I went to college 2011 through 2016, and during most, if not all of those 5 years, I was part of the collegiate squad. Usually we had like 2 or 3 different teams of size, like 3 or 4, depending on what contest we were going to, and I was always on those. I really enjoyed doing that, mostly because like all of it was like funded by the computer science department, so we got to go on these trips, you know, like for the weekend, or sometimes we even got to miss class to just hop in a van, drive for a couple of hours and compete, get a bunch of free food, sleep in a hotel. It was like a nice way to get away from campus for a bit. But I did also enjoy the competitive coding aspect. Okay, so for this test case 1, 2, 3, I'm saying false, but it's obviously true because 1 gets you to 2 and 2 gets you to the end. So this seems like a really no-brainer test case that my code is not handling for some reason. Okay, so let's think about this. Oh, you know what? Let's use the debugger and see what happens. Where do I want to start? Let's start on... let's start the debugger on the first line of the for loop. And, okay, so... So, x is 0. I don't like, okay, hold on. Let me redo this. I don't like line 7. Max of j. Okay, let's do it again like this. Yeah, it's cool. It's a premium only feature, but it's pretty nice. So I is 0, n is 3, and j is 1. So then when I step over this line, oh, j should have been increased to... No, that was right, wasn't it? That was right. Yeah. Yeah, I mean, if you don't have a premium account, that's the way to go. The only reason I have premium right now, like I don't have premium on LeetCode all the time, but I bought it just for like a couple of months because I want to be able to see the problem frequencies because I'm actually interview prepping for the job market right now. Let's run again. I didn't actually see what went wrong there. So J starts off as 1. We come into the loop. J is the max of j, and I 0 plus. Okay, so if I step over that line, j is still 1. You think I fixed that? Should I just run it? I don't think I fixed it. Something's a little wrong with the way I'm updating J and the way I'm checking this condition right here. So I start J off at the farthest we know we can go. Oh wait, I see. I didn't actually fix the problem. So let's start J off at 0, and this needs to be I is less than or equal to J. Is that it? Okay, so that passes the 1, 2, 3 case. Okay, so I think I just had a little boundary issue there. Now I'm back to getting accepted for these 3 cases. Start at 1. Yeah, exactly. Yeah. So that's what I was thinking too. Like I can do this, and then I can start this at 1, and I'm pretty sure that would work too. But that wasn't actually the bug. The bug was, I think, my boundary right here for I is less than or equal to J. But I'm still not sure yet whether or not it's right completely. I'm about to submit. Oh, thank God. There we go. There we go. Thanks everyone for if anyone's watching who just knows how to do this already and maybe knew what was wrong with my code the whole time, thanks for bearing with me. But yeah, so that's it. Yeah. Who is Nathan113? Who's Nathan113? Is he does he also stream LeetCode? Oh, okay, you're good. You're good. I was just curious. What Nathan113. I don't mind random emotes from other channels being used in here. Okay, so that solves it. So that's good news. So the non-DP solution, which actually makes a lot of sense, and I'm annoyed I didn't figure it out immediately. I think the problem was I came into this problem knowing that it was in the dynamic programming category. And so I got in here and I was immediately like, how do I represent this as, you know, like a DP array? But for this problem, it's not necessary. For this problem, the solution is simply to iterate through the array once. So you got linear time and just keep track of the farthest you can go. So every single tile that you're at, the farthest you can go is the max of the farthest you already knew you could go, and I plus the number at that position. And then the important thing is, if you're like looping through and you ever reach I being greater than J, then you've started searching farther than you knew you could go, and that means you're done. That means you can't do it. You can't use the person's emote prefix to find the person. Ah, that's probably smart. Okay, so how long have I been live now? Why is this so much slower than the first? No, this is faster. This is faster. Sorry, if I said it was slower, I misspoke. This is way better. So we've actually improved from, so my first solution was m times n, and we improved it to O of n, or I guess n times m here. So my first solution, n times m, where m is basically the max jump that's present in the array. And I got rid of that. You don't actually need to iterate through the full size of each jump. You just need to mark the farthest you can possibly go, which is J. So it's just a simple max. Yeah, that's why it's faster. Because what I was doing before is I had a loop in here in J, and I started J off at the jump length from this position, and then I made sure that j kept going until, no, sorry. J starts off at 0 or 1. J starts off at 1. And I go all the way until the max jump length from this position. And then also I plus j needs to be less than n. And then plus j. And then what I was doing was I was updating my DP array I plus j, basically saying like true or something like that. So I was for every single tile, I was manually jumping the whole way that you could possibly go, and setting a boolean in an array to be true. Yeah. And then you can definitely get to a working, like a correct solution using this approach, but it's so slow because of this nested for loop. So if you can get rid of the nested for loop, which in this case you can, you speed it up significantly from n times n times m to just n. And yeah, this is the key right here, is just recognizing that instead of jumping the whole way you can go, you're just keeping track all the time of the farthest place you know you can jump to all from the beginning. And then you also have to make sure that you back out if you reach a spot that you already knew that you can't jump to. Okay, so that's that one. I'm glad that I finally got to that, to the solution to that one. I will take a quick peek at the solution tab. Let's see. We call a position in the array a good index if starting at that position we can reach the last index. Otherwise, that index is called a bad index. The problem then reduces to whether or not index 0 is a good index. So this is a dynamic programming question. Usually solving and fully understanding dynamic programming is a 4-step process. Start with the recursive backtrack, optimize with a memoization table, remove the need for recursion using bottom up, apply final tricks to reduce the time/memory complexity. Okay, so what's approach 1? Approach 1 is backtracking, and so I think they just put this in. Okay, yeah, they just put this in here to kind of explain the process. But backtracking, they immediately say it's an inefficient solution, and the reason is because you end up with n squared as your runtime. Very similar actually to the last problem. What was that problem that we were doing before? What was the what was it? It was the one where you were unsorting an array of characters into digits. And so with that I was backtracking, and because I was backtracking, this is probably what I had too. I probably had n squared. Yeah, the scrambled word problem. So backtracking doesn't work for that one, and it doesn't work for this one. Like, oh, sorry, 2 to the n for backtracking. Okay, so then approach 2 is dynamic programming top down. And if you look at it, so this is the n squared solution. The reason this is n squared is because they have, yeah, yeah. So this is probably also TLE. Sometimes they actually label the approach with whether or not it's TLE. I'm pretty sure that this is TLE because I think this is what I wrote, I'm pretty sure. And I got TLE. But anyway, so the reason it's n squared is because you have this loop here, but then inside the can jump from position function, you also have another loop. And then dynamic programming bottom up. Let's see. It's the same. Yeah, okay, I see. So approach 4 is greedy. So that's what we're getting to. The solution we wrote here is greedy, because greedy as in like it always just chooses the best possible route forward. And in the case of this problem, the best possible route forward is always just, basically you're just keeping track of the farthest you can possibly get to J, starting from the beginning. So this solution is also n squared because of the doubly nested for loop. And then approach 4 is greedy. And so let's look at the greedy solution. Can jump, last pause, I equals nums.length minus 1. Okay, so this looks like my solution, but in reverse. So last pause, they start last pause at the end, and then I goes from the end to the beginning. And then if I plus the number at I is greater than or equal to last pause, then we update last pause. Yeah, okay. So last pause is a variable where they're keeping track of, basically they're keeping track of the index that's furthest to the left such that you can reach the end from it. And so then once they get to the end, the question reduces to whether or not that position you're keeping track of is index 0. And yeah, it's time complexity O of n and space complexity O of 1. So this is, I mean, you can look at the two implementations. It's like basically the same thing with the ordering of some things flipped. Okay. Bunch of math. I'm sure that gigantic bucket, you probably know exactly what all this is about. Ooh. This is the best article I've ever read on LeetCode. So detailed, thanks a lot. I hope you keep posting for other solutions. Okay. All right, so we got jump game 1. I think I'm gonna do one more problem for the stream because I've been live for 5 hours. So let's look at jump game 2. So this one does need dynamic programming. So given an array of non-negative integers nums, you are initially positioned at the first index of the array. Each element in the array represents your maximum jump length. So all that's the same. Your goal is to reach the last index in the minimum number of jumps. You can assume that you can always reach the last index. Okay. So let's think about this. So n equals nums.size. Okay, so now the question is n squared good enough for this? So they've already made the constraints smaller, right? What were the constraints in jump game 1? In jump game 1, oh, they only made the constraints a little smaller. So nums.length goes to 10 to the 4th, but the maximum size of a jump is 10 to the 5th. Then in jump game 2, oh no, they made it a lot smaller. Okay. So the total number of jumps you need to do, or the total number of positions is still 10 to the 4th, but then they reduced the maximum size of the jump from 100,000 to 1,000. So they reduced it by a factor of 100. So I'm assuming that n squared is good enough for this, which means we're going to have, I think we're going to have a single dimensional array dp of size n. But then I think we're going to have double for loops. So int I equals, I don't know if we're starting from the end yet. Does it make sense to start from the end and go backwards? Oh, gigantic bucket. I was actually, I don't know. My eye was like kind of looking at the activity feed, hoping that you were going to come through with that follow, but I also wasn't going to ask for it. But yeah, thank you very much for the follow. And hope you, I mean, I'm glad you're hanging out. You know, do come back if you feel so inclined. I'm doing these streams every day for a while. So we need to, so let's see, dp of I. What is dp of I? Min jumps to get to I, maybe? To get to min jumps to cross all the way 0 to I or something like that. And then if we do it like that, then dp of n minus 1 is the answer. Yeah, Gigantic Bucket, thank you. You actually helped me exceed my follower goal, which is the first time that's happened. And I think I've actually gone live on this account, on this channel, like 6 or 7 times. I don't think I've ever had 6 followers in a day, so that's hype. Thank you very much. Okay, let's think about this. Is this right? So dp of I is the min jumps to cross all the way from the beginning to I, which means that dp of n minus 1, cheers, for sure, is the answer. So this looks good. The question is, how hard is it to update this? If we were to do it this way, the base case might be let's see, let me move these down here. The base case would be like dp of zero is 0, right? Because it takes you no jumps to get to the start. And this is going to be a minimization problem. So what we probably end up doing is initializing all of these to be really high. Numeric limits, integer max. So maybe we just update all those to be the largest possible integer that they can be. And then we set dp of 0 to be 0. Let's think about this. Yeah, I think this is gonna work. I think this is gonna work. I don't know, let's just try it. I'm gonna code this up, this idea. And then if it works, it works. If it doesn't, I'll try to figure out why it doesn't work. So the answer is dp of n minus 1. The problem description guarantees that you reach the last index. So I don't have to worry about actually returning this value from the function. Got to run for the night. Good luck with this variation and the practicing in general. Thank you. Honestly, it's been great to have you in the chat. I hope you come back. Yeah, thanks for everything, and have a good night. Yeah, catch you later. I'm not going to be around much longer either, so I'm hoping, fingers crossed, to knock this one out with relative ease. So far, I feel good about the approach, and then that's going to be it for me, because I've been coding on LeetCode for a while today. Okay, so we start I at 0. No, we can start I at 1. I is less than n plus I. Wait, is this right? Is this right? What am I missing here? Maybe I do this backwards. No, this is good. This is good. This will work. I think this will work. So I do have to start off at 0, because 0 is like the position that I know that I'm looking at, and then I'm gonna jump ahead from it. Yes. So int I is going all the way through, and so there actually is an index we can skip, and that's the last index. Doesn't matter what the last index is. because the question is just reaching it. So the fact that there's a 4 here and there's a 4 here doesn't matter. All that matters is the 2311 and the 2301. Okay, so for each index, we want to check out the whole jump that you can do from there. So for int j equals 1. Yes, j equals 1. J is less than or equal to, the maximum size of a jump from this position, which is nums I, plus j. So we're iterating. This is the thing that we didn't want to do in the last problem, but that I'm pretty sure we need to do in this problem, is for every position, we're checking every step of the jump. Now, we want to update. Okay, so let's do this. J is less than num sub I, and I plus j needs to be less than n. So then what we're going to do is dp of I plus j equals dp of I. So dp of I is what we currently know is the best possible distance that it takes us to get to position I, right? So dp of I plus j is dp of I plus j. But we actually, we need to do better than this, because we're checking a bunch of I plus j's for every I. We're going through the whole jump. We don't want to overwrite a better value, right? Like, let's say that we calculate dp of I plus j to be 3, but what's stored here is already 2. That means that 2 is better. And since everything starts off as infinity, we can just minimize here. So dp of I plus j is the min of dp I plus j, and what we currently calculate as the distance to get there. Is that it? What happens if we run the code? Wrong answer. What's wrong? What did I miss? Let me read through the code again. Wait, so hold on. Let's get all the test cases. And hold on, let me run both of these. Output 44, expected 22. Is this right? Oh, wait. Okay, let's jump back into the debugger. Okay, so nums is 23114. I is 0, j is 1. Okay, so we're at the start, and we're trying to jump 1 away. And this is our DP array so far. So step over. Okay, we get 0, 1. That looks right. Let's just do this a couple more times. I just want to see what the DP array looks like. Hold on a minute. Hold on a minute. 0, 1, 2, 3. Is that right? It's definitely not right, because like 2 means you can jump here in 1. Right? So what's wrong here? Wait. This needs to be dpy plus 1. Is that it? Ah, yes. Yeah, so for example, if you're jumping from 2 to, let's say you're jumping from the first element to the third element, the distance only increases by one jump. But I was adding j, which is the size of the jump, and that's just not right. So let's submit. Fingers crossed. And we solve it. Okay, so we solved this problem. We're faster than 25%, less memory than 42%. Those aren't great results, but let's submit a few more times and see what we get. Okay, so the range is it's all pretty slow. So we're only doing better than 20% of the submissions, but it is correct. It is accepted. So why is it slow? That's the question. There must be some way that we can speed all this up. Maybe starting from the end is the way. You know what? I've been coding for long enough. I got it accepted. I'm clicking on the solution tab. I don't care anymore. Alright. Let's have a look at what they've got to say here. To find the minimum number of jumps, the brute force would be to exhaustively test all the routes. This can be achieved by backtracking. Also, feel free to check out our backtracking explore card. The problem is very similar to the jump game. However, an exhaustive search would lead to time limit exceeded. Yeah, we know that. So approach greedy. Let's take a look at greedy. Imagine you are at index I in the array. The element in your current position defines the maximum distance that you can jump. Therefore, your next step will fall somewhere in the range start end. And end is I plus num's I. The question is where to jump. If you greedily jump as far as you can, you may end up in a place with a small jump power. Right? Yeah, that makes sense. That's why it's an optimization problem. You could jump one away because in doing so, you get a lot more jump power for the next jump. As you may notice, we're using a greedy approach. Always jump to the place that will take us farthest. Greedy algorithms always make locally optimal decisions, which may or may not lead to the globally optimal solution. Therefore, we must test our greedy algorithm to see if we can prove that it leads to the globally optimal solution. We will use proof by contradiction to verify that greedy algorithm is correct. Wait, so it works? Our statement is, if at any step we make a different choice than what our greedy algorithm would make, we can find a better solution to the problem. I didn't look at the code, but I did see that there is a linear solution here. And it's because you're greedy. It's because you're being greedy. You always want to jump as far as you possibly can. Okay, so as shown in figure 3, consider two people A and B, where A follows our greedy strategy and B follows the optimal solution. The number at each index defines the maximum jump distance. Let's assume that until this point their decisions have been identical, and this is when the disagreement happens. Notice that the choice they make for this jump will define the subarray for the next jump. The greedy solution always picks the largest subarray. Thus A will have a larger subarray than B. Henceforth, it's not possible to beat the greedy algorithm at any step and reach the end of the array in fewer jumps. This contradicts our statement. Man, it's 11:45 p.m. here. Okay, so little dude's at the 3, which means he can go to 5, 2, and 1. And I guess the idea is you just take the 5, right? Okay, hold on. I'm trying to prove this to myself, and then if I accomplish doing so, then I'll decide whether or not I'm gonna code this right now. Imagine that you are at index I in the array. The element in your current position defines the maximum distance you can jump. So you can go here, you can go here, you can go here. Therefore, your next step will fall somewhere in the range start to end, where start is the place right next to you and end is I plus nums I. Then the question is where to jump. If you greedily jump as far as you can, you may end up with smaller jump power. Okay, so I think I'm trying to figure out what exactly it's saying here. So it's definitely saying that we jump to 5. Like that's what it's saying. Our jump is going to be of size 1, so that we end up at the 5, rather than jumping as far as we can, ending up at the 1.
We get so wrapped up in numbers in our society.
So wrapped up in numbers. Dude, man, I'm hungry. I need some food. Okay, let's look at the code. Man, it's so beautiful. So you start jumps off at 0. Current jump end is 0. Farthest is 0. Okay, so it looks like they're doing some of this is how I approached the last problem. They're keeping track of the farthest. So they iterate through all the i's, continuously find how far we can reach in the current jump. So farthest is the max of farthest and I plus nums I. If we have come to the end of the current jump, we need to make another jump. Ooh. Interesting. This person here says, I was using the n-squared dp method in a Microsoft interview and was passed. No need to remember the greedy method. Yeah, this is our approach here. dp of I equals the min of dp of I and j plus 1. What are the replies? Oh wait, someone got TLE for that? No. Another way to do DP and get accepted. Okay, anyway. Let me see if I can convince myself that this is right. Which it is. But I want to be 100% sure that I understand why. So your jumps is 0. You're keeping track of basically of the answer, right? Jumps is 0. Every time you do a jump, you increase that by 1, and then the answer is the number of jumps you did. Okay, next. Current jump end equals 0. That's like the end of the current jump, which is 0. Okay. Farthest is 0, so you just start all these off at 0. Then you iterate from you iterate with I from 0 to the end over all the indices, and continuously find how far we can reach in the current jump. Pardon me. So farthest is the max of farthest and I plus nums I. So at any time, you know basically the farthest you could possibly go from everywhere you've been so far. So if we've come to the end of the current jump, we need to make another jump. Oh, I think I understand. If I equals the current jump end, increase the jumps, and the new current jump end becomes the farthest. And another thing is this solution doesn't take into account not being able to reach the end, but the reason that it doesn't take it into account is because they guarantee that you can reach the end. So that's why they can always just keep track of the farthest you can possibly go. Then once you jump as far as possible in the previous jump, your new farthest you can jump is your new current jump end is the farthest. Okay, that kind of makes sense. I'm not 100%. I haven't 100% proved it in my brain to myself that that's right, but it's starting to make more sense. I might take another look at this one tomorrow, maybe. Also, there's a lot more jump games in this series. Jump Game 3, Jump Game 4, Jump Game 3, Jump Game 7, Jump Game 8. And then if we look at the dynamic programming study plan, is that it for jump games in this? I was just looking ahead to see what problems were coming up. But okay. So we got these two. We got Jump Game and Jump Game V2. Tomorrow I'll most likely take a look at these two. Maximum subarray. Maximum sum circular subarray. And then there's a lot more DP to come. But I'm going to keep working through those. But alas, that is going to be it for today. I've been LeetCoding for 5 hours and 20 minutes. That's plenty of LeetCode for one day. Some might even argue too much. So I'm going to be calling it. Anyone who was here, who just watching, thank you. Anyone who was here active in the chat, thank you. Anyone who was here and followed, thank you. I really appreciate it. I'm glad that people are tuning in for these streams. Morgan, thank you so much for being here. I hope you have a good night. I do want to point out that this Twitch channel, I'm going to keep streaming on it even once I finish the LeetCode grind. I have other types of coding that I want to stream. So it's LeetCoding oriented for now. And I'll probably always have like some LeetCode-esque stuff going on. Like maybe I'll do the weekly contests or something like that. But at some point, I am gonna shift gears and get more into development, like actual software development. And there's I have some ideas for like side projects and stuff, little web apps and stuff that I can build live on stream. So I'm gonna do all that. And tomorrow when I start the stream, I might come back to Jump Game 2 and try to implement it in linear time. Or I might not. I have no idea. But yeah, so that's gonna be it for the stream. Once again, thank you everyone who's here. And hopefully I will see you tomorrow. Good night. Good night, Morgan the Third. Thanks for hanging out in the chat. Peace.